Wow, what an intro. I love that graphic. It's absolutely awesome. Welcome, folks. Welcome to the EMEA leg of DevSecCon Lightning 2022. I'm Matt Jarvis. I'm Director of Developer Relations at Snyk. And I'm joined by my fantastic co-host, Brian Vermeer. He's a Java champion. He's a developer advocate. He speaks all over the world. And I've heard you're a big fan of Orange, Brian, at the minute.
I am absolutely a big fan of Orange. That's something to do with some competition that's going on.
I don't know what's going on. Yeah, I've heard things.
But I'm absolutely supporting the Orange, wearing it with pride, and hopefully after tomorrow we'll still do the same. But hey,
yeah, good luck to everyone. So, what do I need to tell you? So, APJ was a fantastic success. I managed to catch up with all those sessions on fast forward in the last hour or so. So I've had a chance to skim through them, but it looked like a fantastic event hosted by our friend and colleague Filipi. I particularly liked there was a presentation on Salsa, which I think is super interesting. Salsa is a framework for making sure that your supply chains are secure, and supply chain security is a big deal at the minute. I also really like Brian, the Randall, who's our boss, live writing his talk using ChatGPT from OpenAI, which is super cool and something I've been playing with.
The question, are you forced to say this, or like he is our boss in the end, right?
So anyway, we've got a whole lineup for the next, I think we're with you for the next 4 hours. Some fantastic talks. Some housekeeping first, I guess, for everyone just joining us. So first of all, perhaps I'll try and get the, let me get the,
shall I put the hop-in screen?
Yeah, if you could put the hop-in interface up, Brian.
Absolutely. Well, let's
and we could just point people in the right direction for those who are just joining us.
So if you signed up for this event, you will end up at this screen. If you did not sign up, you can go to DevSecCon.com, and with some clicks, you end up at DevSecCon Lightning. You can register, and that's basically it. So you end up at hop in, let me put the right, and you end up in the reception. Well, we have a couple of things. We have chats, and this is the event chat. You could just say things in there, and we have stages. So if you go to the stage, you will see that we're now kicking off the EMEA stage, the EMEA leg. Go into here again, you will see the chat. This is the stage chat, and you can ask questions during every talk in this stage chat. It's separate from the event chat, but we will monitor both of them.
Yeah.
What you can do is,
Brian, the big schedule button at the top. I'm guessing that brings you to the schedule for the event.
I think so. Oh, there's schedules also over here, and you see that the schedule is ongoing. So this we're just kicking off. Me and you and Rouan will join us later. Next up is Or, and I see Or is already backstage, so I'm pretty excited for that. The 5 layers of modern app security, and so on and so on. So you can see what's going on and who's actually speaking. So if you want to see when your favorite speaker is on, go to the schedule and you see it outlined. It's just a one-track conference, so it's pretty easy to find out.
So if you need any technical help, we've got a full support team, haven't we, hanging out in the DevSecCon Discord, which you can get from the button on the left-hand side, or you can also go to DevSecCon.com and get all that good stuff there about how to join Discord. I highly recommend joining that Discord. Actually, it's if you're interested in anything around DevSecOps and security. There's a very active community in there and lots of interesting security chat going on.
And you see that there's already a join us in Discord button over here that clicks you directly to Discord, or you see now down below, you see the URL to join our Discord thing. And you can keep continuing chatting about whatever you see, what questions you have, what follow-up questions you have, because most of the speakers are also active in there. We are active in there, and it's just fun.
Right, we've got to keep an eye on time here, Brian. Enough chatting from me and you, and more chatting from our keynote speaker for this session. Welcome all from Permit.io. Let's
pleasure to be here.
Fantastic.
Good to see you again, Or.
I seem to have a cloud over my head in this layout here, but let's add your slides to the stream, and Brian and I will get out the way, and the floor is yours, Or.
Thank you. Hi, everyone. I'm excited to be here. Today, we're going to talk about Dark. Dark is a framework, a methodology to work on DevSecOps. A little before we dive in, a little about myself. My name is Or Weis. My background starts in the intelligence core in the IDF. But at core, I'm a developer and a security practitioner. Nowadays, I'm the founder and CEO of Permit.io, a access control solution. We basically enable you to never build permissions again. And I'm also honored to be a SNCC ambassador and try to promote cybersecurity and best practices for developers around the world. Without further ado, let's dive in. So one of the challenges that people are facing today, and it's probably the opening statement for almost any talk you hear today, is the complexity of software. The software stack that we're building is getting bigger. We're adding more parts. We're adding more layers. There are a lot of weak links that are added into the chain, and this just translates to a lot of attack surfaces, essentially attack surfaces all over the plane. And a lot of times when we try to communicate with our team, trying to communicate with vendors that we're working with, trying to communicate with customers we're serving, trying to communicate between DevOps and security, it can be very challenging just to wrap our hands around all of these surfaces. And sometimes it can feel like we get lost in the dark. To kind of give an example here so we can understand what I'm talking about, I have an example here of a healthcare startup that does something rather basic for a healthcare startup. It connects with something that they deploy on the hospital side, and then they provide a machine learning driven service with a backend part and a front-end application to their customers, which include both patients and doctors that work on that data. They have data scientists working in the background to build a machine learning model, to train it and load it to be used in inference. They have the platform engineers kind of sculpting and planning everything, and obviously R&D building all of the elements here. And just looking at this picture, I think it's already kind of jumping out all the different points where valuable and sensitive data is flowing through the system, where proprietary aspects of the system, like the model here, reside and can be translated into attack services and into vulnerabilities that we have to take care. And just trying to communicate what's going on in this picture and trying to cover all the areas, that's kind of going to take a while, especially if we're going to do this in a way where we are connecting to other partners or vendors or solutions. This is extremely clear when you think about security questionnaires. So anyone who's ever built a product, a SaaS offering, or another one that you cater to a different company, you are probably familiar with these documents, usually long spreadsheets that you need to fill just to communicate the baseline of how you do security, how your product looks, and how it's going to affect the security posture of that customer you're interacting with. Just filling this out can drive someone insane. I know I've filled probably thousands of these by this point, and it can be very stressful, annoying, and also very hard to work with. So that's kind of at the core of the problem that we have. The plane surface itself and the attack surfaces within it are constantly growing. It's hard to communicate. It's hard to work around. It's hard to find where we have gaps and potential weak points that we need to take care. And this is where Dark comes in. So Dark is a new methodology, a framework that is focused on being very quick to provide you with a quick top line so you can communicate quickly within your company, between devs and ops, with your customers, maybe instead of security questionnaires with other people, and give you a very quick picture of what's going on, help you find all the points that you need, have coverage for it, enable you to zoom in on different levels so you can have an overall picture, but also apply Dark to more subsets of the problem, and everything very consistent with best practices, and no less important, tools that we can apply to the problem itself. So let's talk about what Dark is comprised from. So first of all, Dark is the 5 layers of basically every application. So no matter what we build, these 5 elements are going to be in existence there, and we need to take care of them. And not taking care of them is immediately translates into potential security vulnerabilities. So the first one, and I think our host here mentioned it at the beginning of the talk here, supply chain. That's a really hot topic now. And so managing dependencies, the dependencies of the software we're building, software we're providing, is a critical thing. So dependency, that's the first layer in Dark. And we basically ask, how do we secure the software supply chain that we're providing? This second part is access control. How do we connect other services? How do we connect other people, other identities to what we're building, and how we do so in a secure way? Is a classic question. We move forward to runtime. How do we know that the software that we've built is going to behave the way that we expect? Configuration. How do we know that we've set and configured the software that we're deploying to run in the way that we expect and want? And lastly, the container. How do we set up the containing environment? How do we make sure that our software is running within the box, within the servers, within the cloud that we intend, and in the way it is intended to work? So those are the layers, and now we're gonna cross them with the best practices. These best practices are really going to be our light in the dark here, something that you can take with you, apply on those layers, and be able to say if you have any gaps in your security. The first one is managing as code. So that's really a classic one and becoming more and more popular. Knowing that we have a very mature ecosystem with how we manage complex things as code for developers. Now we know that we can apply this to basically everything else. We can apply these to policies, to infrastructure, to configuration, to basically all of the layers that I mentioned before. So we want to see that we can apply management as code across that stack. Zero trust. That's also a very common best practice. We need to make sure that what we're building has zero trust and need-to-know bases kind of baked into all of its layers. This will really affect how we compile or how we build the software itself and how we connect different software components between one another. Being event-driven, that's just a necessity of modern applications. If we're moving too slow, if we're not real-time, if we're not responding to changes both in the customer demands or in our infrastructure, we're going to have a bad time. So being event-driven, that's a must nowadays. Decoupling, that's a classic from software development, just making sure that only the parts that need to be bundled together are bundled together, and that we have tools that allow us to separate the different parts that we have. If we don't do so, because of the complexity of software today, we're going to end up with spaghetti code or spaghetti architecture within a very short window of time. Lastly, the two more high-level ones, a unified view. Unified view just means that we are able to monitor that entire layer in a way that is easy, aggregated, and we can connect it to other systems and have it approachable. Here we understand that, first of all, everyone is becoming a developer, and all the stakeholders have to be involved in security. We can no longer apply security as an afterthought. So we need developers to take care of it at day one, but we also need to enable all the other stakeholders, product, security, compliance, even sales and support. We need to enable them to chime in on our security posture, or at least be part of the conversation. Otherwise, we're going to have a bad time just trying to communicate. So these are our best practices, and now we're going to layer them on top of the layers. And so now for each dark layer, we're going to look at each of the best practices, and we're going to ask, how are we implementing the best practice? And even more specifically, how are we applying tools to implement that best practice so we know we actually solve the problem and we're not just talking about it? So I'm going to run quickly through kind of these overview of layers. I'll mention the top tools that I think are worthwhile knowing. And then we'll try to bring this all together back to the example that we've set on the stage for. So dependency, our supply chain. So I'll highlight managing things as code. So SBOM, software bill of materials, is becoming a very commonplace thing. You can find tools for that both in an open source project called SPDX and also within Snyk Cloud. I'll also mention things like Backstage and Port.io, Get Port.io. Starting to manage all the different software components that we have in an approachable way that the developers can manage, share with one another, maintain track of what's going on. That's becoming super important and super critical. And these are tools that are becoming popular to solve that. There are other things here that are maybe worth mentioning. Classic Snyk for your open source dependency. And obviously being event-driven here translates very easily into CI/CD. Access control. So access control has multiple layers by itself. So we have application level access control, infrastructure level access control. And obviously it continues to the network level, physical level, and we need to cover that across the space. Policies code is really solved by great projects like OPA. And now fresh out of the oven, AWS announced a policy language and engine called Cedar. Zero Trust is really managed by the classic concept of doing policy decision points. So instead of having access control baked into our software, we have a separate microservice for authorization, usually called the policy decision point. And we have services like Permit.io and like SpiceDB that we can use to implement that microservice for authorization instead of building it on our own. So those are like a few quick highlights for access control. Moving into runtime, here Snyk code also comes in for our decoupling aspect. I also want to highlight Falco. Falco is a really great project for runtime application security, really can produce quick alerts. It's also becoming a very popular CNCF project. Gatekeeper with OPA again comes in for policies code, and Docker is a classic for containerization and basically creating that zero trust element between the different runtime components that we have. Configuration, I'll mention configuration checking tools like ConfTest, the tree, and Checkov. These are also becoming, I think, a very common tool in the arsenal that developers and DevOps use today. GitOps as a methodology to be event-driven around configuration is very commonplace. And we're starting to see configuration management solutions that make it more approachable with things like Configu and, again, Backstage that I mentioned before. Lastly, container. So here, obviously, Docker, Helm charts with Kubernetes and OCI images really shine. Management tools for the overview of it, like Datadog and Prometheus, are very commonplace. And we're starting to see some maturity around making this more approachable with projects like Raft, Velocity, and env0. So we went through the layers now, and we looked at common tools, or at least examples of common tools that we can bring to the table to try and manage all of the best practices that we need to bring in. And we saw that for each layer, we can look at each of the best practices, and we can apply it in a general fashion. Just in general, how can we go about making sure that we have the right best practices and tools for whatever we're building? Now let's take this back to the specific example that we have here. So we can do two things. One, we can create a quick picture of dark to light up this entire thing, and that's going to be the next slide. But we can also talk about having different points. I can look at, for example, how the data scientists connect to the machine learning model, or how the CI/CD connects to the backend, or how the platform engineers connect to the CI/CD and the backend. For each of those, we can create a dark map. We can apply the framework for each point. So I'm not going to do that for now, but I'm going to do this for the overall picture. And you'll see that we quickly get basically a component that enables fast communication, quick summary, and the ability to kind of zoom in on the parts that we want. And let's just jump into that. So if before we looked at each of the layers separately and we asked in general what we can apply here, here we're looking at all of the layers together, and crossing them in a table with all of the best practices. And we're applying this to the specific case of that healthcare startup that we saw before. By the way, that healthcare startup is a real startup. I didn't mention their name here, but this is based on something that's happening in reality. I know them because they're a customer of mine with Permit.io. So for example, we can see that for the access control part, Permit.io is a solution that they use to solve both decoupling, creating a unified view, and making this approachable for the other stakeholders. And also with Permit.io and Opal, the open source project behind Permit.io, they are able to do this in an event-driven sense. Like many other players, they're using Snyk, both for their supply chain and both for their runtime security. What was interesting in the picture that we saw before, and maybe I'll go back, is that there's both a cloud component and an on-prem component. So in this table, I've kind of broken it down both for on-prem and for the cloud. And that kind of floats up some issues. So for example, in runtime, being event-driven, they're using Falco and a web application firewall to monitor in real time what's going on with their running code. But for the on-prem solution, they don't really have anything. So immediately, just off the bat, looking at the slide, we immediately see where do we have gaps. And in this case, we see that we have a partial gap. We can also see that there are areas that are complete gaps. So for example, they have around configuration, they have a lot of gaps. They're not event-driven. The configurations are deployed once with the basically with the build. So you build it once. If you want, you have to redeploy everything to change configuration. So they're not using anything like feature flags or anything like that. And for the on-prem option, it's completely not event-driven. They have to deploy, they have to send a new image to the customer to have any configuration change on that side. So obviously it's not decoupled, it's bundled into that image, and they have no way of viewing this or making this approachable, not for themselves or their customers. Obviously, what we're covering here is that specific case for that specific customer of mine. Different scenarios that you'll run, your software, the interaction that you have with your vendors or your customers would produce obviously very different slides, very different dark maps. But you'll get these dark maps quickly. It won't take you long. You can probably, if you take your average mid-sized SaaS offering, it will probably take you just a few hours, a day at most, to map everything that you want into a dark map. And then you can use that to communicate internally. You can use that to share it as part of security questionnaires, or maybe in the future instead of security questionnaires. And you can use that to also find gaps in the software that you have or in the solution that you're building. And I think this slide really kind of sums up the way that Dart can really light up our look into our security posture. So kind of summarizing up what we talked about, Dart is relevant for anyone building software, developers, DevOps, SREs, AppSec, and everyone managing the overall picture, architects, security analysts, AppSec, the management team. And it can be a valuable tool to speed up processes on both those sides. For the management, this can really be a guiding principle. When you're starting to build something new, or you're refactoring something, you're working on new architecture, you can start with a dark map to kind of quickly highlight where you have answers for things and where you have gaps that you'll need to address soon. And this can be a way to communicate between organizations. Again, I really think that security questionnaires are a pain in the ass. And even though we have companies like Panarise making them easier to approach, it's still very cumbersome to work on. So I'm really trying to encourage this. And this can also be a good way to communicate security as part of your docs. So a lot of documentation for SaaS offering today's or products today's include a section on security. Having this as part of that security section would really speed up someone's ramping up into the project and them being able to find the answers for what they need and how they can make sure that the product that they're reviewing is meeting their standards. For developers, this is foremost a checklist. You build something, you want it to be secure, you can go through the checklist through the dark map to make sure that you have an answer for all the different things you're connecting. And this can be also a baseline for a SWOT analysis to understand where your strengths are, where you have gaps, where you need to invest your time when you're dealing with technical debt. And in the end of the day, this can also be a good way to decide which tools you need to invest in. Knowing what you have in place, knowing which gaps you have, prioritizing them, and understanding which ones are more critical can enable you to decide which tools are you bringing on next. Are you upgrading your observability? Are you adding runtime access control? This map can be a baseline for the discussion of what you should tackle first to minimize your technical debt and to basically meet all the best practices that you need to meet. So now I'll pause for questions. I'll say I'm available for questions later. You can find me all across the internet as Weis, Orweis, on GitHub, on LinkedIn, on Twitter, and you'll be surprised how responsive I am for questions. If you want this deck and you want the framework itself, you can find it at Permit.io blog Dark. Dark here is obviously DARCC, and it's available for everyone. And if you're interested in best practices and other concepts that I'm driving, you can also check out this blog on Permit.io for the 5 best practices for building cloud-native permissions. Hope you enjoyed the talk, and I think we have a few minutes left, and I'll be happy to tackle questions if there are any.
All right, thank you so much, Or. And yes, let's put Matt in as well, and let's change the view for a second to this. Oh, I will put the overlay away so we can actually see you, Matt. Like, let's do it like this, and we just put the little logo in. That suits far better. Thank you for this talk, Or. I don't see any questions that were not yet answered in the chat, but I would love if you could share the links that you have on the Discord as well, so people can click on it, because it's very hard to click on slides, obviously, because I think that the whole story about Dark and how to implement it, I want to get my hands on it and actually try it just to see if it fits. So thank you.
Happy to share those, and I think that's something that I really want to encourage people to do. This thing that I've presented here is really geared towards simplicity and being quick. So you shouldn't thinking, oh, should I adopt a new methodology? Should I adopt a new framework? I think you should put that question aside and just give it a try. I think most people and most other companies that I've used this framework with, you quickly find gaps that you weren't necessarily aware of before. So even if you don't end up implementing this end-to-end or across your stack, this will enable you to figure out things that you might necessarily not be aware of, and that will immediately improve your security posture just by raising awareness.
We have. I had a question that I'd be interested in your thoughts about. I mean, I'm always fascinated by. Actually, we've got a question coming.
Yeah, we got a question coming in from the Hoppen framework. So, or where does API security come? What are your views about it?
So API security is a component of itself that you definitely want to have. I didn't map all the different components that you have. I mapped the best practices. And API security, you'll have both access control, I think, is a significant part of it. And while you go through the best practices, you'll end up basically implementing API security both in the access control aspect and in the runtime aspect. So the challenge with trying to build a framework around specific components is that it doesn't end. There's always another layer being added. So, and that will make this framework complex instead of simple. So that's not the direction I went with, but I think Dark definitely touches on it. And anyone building anything with an API, going with Dark to light it up will definitely touch on API security. It's unavoidable.
Yep, I guess so. So thank you for that. Matt, you had something, so go ahead.
Yeah, I mean, I'm always fascinated to see that folks are still trying to manage things using spreadsheets these days, especially in the era of modern software development where, an application might have hundreds or even thousands in some cases of dependencies, which is just, that's like trying to fit a square peg into a round hole, right? I mean, you're just never going to be able to track things like that and look at the risks of them. I still think that the answers for how we do that are still emerging. I know we've got a couple of talks later on today that are around the same space. I mean, I guess the other thing was when we start to look at complex application architectures, and as you pointed out in some of those diagrams, we're often also having requirements on external services, right? That we're using SaaS things within our apps. What are your thoughts on kind of how we quantify risk for that, right? Because do we just say here's a risk boundary, that's somebody else's problem, and that's enough, or
So I think, first of all, maybe to touch on the spreadsheets. So I'm not saying here that you shouldn't have those spreadsheets. It's okay to have them. It's a good tool if you want to do a deep analysis. I think they're really not a good tool if you want to communicate between boundaries, which is kind of the other part of the question that you're alluding to or touching on. So if you're working between vendors or between customers or between different departments, if you're passing around spreadsheets, everyone's going to have a bad time. It's just not something that people can digest fast enough to build a conversation. So you can add those spreadsheets alongside something that will give someone the ability to ramp up quickly and communicate quickly around the sensitive areas. And going to your second point, so Dark doesn't really touch on prioritization directly. It's more focused around highlighting where you have gaps, and then there's more work to be done around prioritizing them. But I find that especially with security, if you're prioritizing things without a clear unified view, you're basically missing out. Because the weakest link principle might be hiding the actual thing that if you don't take care of, all the other work that you're doing is basically meaningless. So I think should be foremost managing a view, being able to communicate around that, having the discussion of what we have in place, and then being able to prioritize. Maybe in a future update to Dark, like Dark 2.0, maybe I'll add something around prioritization, but I haven't tackled that specifically yet.
Great. Well, thank you very much. That's super interesting. Oh, we've got one. Have we got time for? Yeah, we've got time for one more question. I think we've got one. Do we have that on a banner, Brian, or should we just read that one out?
Let me put this on a banner in.
Okay, well, I'll read it while you're typing. So, how does threat modeling fit in with the framework, and how does threat modeling fit in with permission management?
Ooh, that's a lot in one question. So I think threats, and I kind of touched on it with the SWOT analysis. So the gaps that you have are almost always translating into potential threats and risks that you have. So, and that's also kind of touching, I guess, on your question before. So once you have those gaps in place, you can map them into risks and threats, and then you can prioritize them, and then you can create models of them, and then you can even have simulations around tackling those threats when they happen. It's not something that this framework specializes in, but I think it's a good enabler to do threat modeling. In terms of modeling threats and connecting them to permission management, I'd say that it's around policy, and policy is code specifically. In general, managing policy in complex applications is becoming very, very cumbersome. If you try to keep all of that as know-how and documentation that you have proprietary code for, it will be very hard for you to keep modeling the threats or the friction points that you need to protect with your permission management for the software component you're building. If instead you decouple out your authorization, if you decouple that out and you have your policy managed separately as ideally as policy as code in a unified repository, then it's easy to have a source of truth. And then that source of truth you can model, you can track, you can test, you can do benchmarks on, and you can also have code reviews on it, which is an amazing feat that is impossible any other way. I'd said that in addition, if you use tools like obviously I'm biased here, but if you use something like Permin.io, you also get low-code interfaces that generate that code for you. So that way you can have the security practitioners work directly on that policy as code, on that source of truth, without having to necessarily be full-blown developers.
Fantastic. Well, I think that's actually a great segue to our next speaker. So we'll leave it there. Thank you again. Or that was super interesting. And let's drop you out and bring to the floor our next speaker, Chris Nesbitt-Smith. Good morning, Chris. It is still morning, right? I'm losing track of time already.
Just about.
It's morning for you, but not morning for the rest of Europe. Come on, you're the last one.
It's fine. We're the ones that define the time, though, so we'll set it on our own basis.
Fair point. Fair point.
Right, let's move things along here. So I'm going to add your slides to the stream here, Chris. Hopefully, press the button. There we go. Brilliant. Cool. So the floor is yours.
Amazing. Yeah. What better setup? Thank you very much. Cool. So. This is I think it's great to be here. Thank you so much for joining me here today. So, elephant in the room, policy is a dull thing. It's kind of hard to make it sound sexy, but I'm going to at least try and get your attention. So, bear with me. So, to set the scene, I'm in a lift, and yes, any American friends, we really do call them lifts, and 4 people walk in. I think to myself, Chris, this is your moment now or never. As the doors close, I position myself in front of them, a captive audience. They're mine. I've got them. I hear the doors still shut behind me as I take a breath. I look to the first person on my left. She's in a suit. She looks really important. I gesture to her, see? She looks back at me as if to say, yes, go on. She nods. Oh, perfect. The CIO, the policy maker, the one whose neck is on the block. Well, what are the chances of finding you in my imaginary lift today? Well, I ask her, well, what keeps you up at night? Well, she tells me, I don't know what teams are really doing, what's the volume of risk, and what I should be showing more interest in. Setting and changing the policy is slow, hard to communicate, and people just go off and do their own thing. They think they know better, and to be honest, often they do, but then I'm left playing catch-up with the risk that they've signed me up to. Okay, I say, try not to sound like a patronising snake oil salesman. I can help. I turn my attention to the second person, also in a suit, but look less important. I make a guess. Let's face it, this is my imagination. It'd be weird if I was wrong here. Product manager, I say. They nod. The whip cracker. I say, well, what's important to you? So managing risk, mostly opportunity risk. So the fear of missing out. So getting features out of the door and avoiding getting bogged down with, as they glance to the CIO, bureaucracy that is almost designed to slow me down. Awesome, I say. This is your lucky day. I turn to the next person, dressed in overalls. I'm in a trendy part of town. They could be the CTO, but before I ask, they sense me staring at them. Cleaner, I say. Oh, okay, hold on. How did you get into my imagination? I'll come back to you. My attention goes to the last person, hoodie, headphones around their neck. My stereotypical developer. Yes, I know you well. What code do you write, I ask? It doesn't really matter, but Python. Have you got everything updated to work with? As I pause, Python 3, they say? Python 3, yeah, that must be really hard. They don't know it, but I've kind of informally won a bit of their trust, which is, after all, important. Nearly, they say. Cool. Okay, well, what's important to you? So staying on top of patching dependencies so that we can react to the next fire, knowing what rules exist, what ones I can bend, and what I could break, and what ultimately might cause me to lose my job. Writing consistent, good quality code and avoiding technical debt. So the rest of my team being able to cohesively work as one. Do you use any tools to help you with that, I ask? Well, yeah, linters, code quality, test coverage, the kind of usual. Great, I say. I wrote code too. Let's be friends. And I hand them a printed QR code and say, here's my public GPG key, so you know that you can trust what I have to say. I return my focus to the cleaner. I've got it. How do you get told what to do and then when it changes? Well, we get a memo or something stuck to the notice board. So last week we got a memo saying that all the meeting room whiteboards needed to be cleaned every night. Interesting, I say. How does that work out? Well, it's up to us to then maintain the to-do list so that we can onboard new people. Does it go wrong at all? Well, yeah, sometimes if we compile our operational manual wrong, we miss a memo, don't apply them in sequence, we do get things wrong. So they glance apologetically to the product manager, like when we hadn't updated the guide that the meeting room on the 3rd floor was being used as a dedicated war room, and we wiped all their boards down. I looked at the dev. Does that sound familiar? They nod. Turns out we're not all special snowflakes, hey? All is not lost. I knew that there was a reason that I imagined you here. The lift is slowing. I feel it coming to its destination. Great. I've got a silver bullet for you too. The CIO looks to me, ready to buy literally whatever it is I'm selling. They ask me as the doors open, who are you and what team are you in? As I move out the way to stop obstructing my answer, well, I don't actually work here. I'm just here to fix the lift. People have been complaining it only goes to the top floor no matter what button they push, and it's actually pretty slow. My audience storms out, furious, heading towards the stairs. The door's shut. I get back to my job. Okay, so if any of this might sound vaguely familiar to you, then and you can relate to some of my imaginary friends, then I've got answers for you. So what if I said you could update policy easily, even releasing several version updates, not just in a year, a month? What about 10 updates in a single day? And seamlessly communicate those to the people that need to consume it, all without derailing them. You could have visibility on compliance using tools that you perhaps already use. And that the policy could be readily consumable, easy to pass, demonstrate compliance, and make sense, not be bureaucratic to change when it needs to, and ultimately not get in the way. That same policy could be treated as a dependency and operate like a linter. So you can run compliance checks locally and in CI, and then onwards kind of guard production. Multiple versions of a policy, like a dependency, are supported. So emergencies like you must update now because there's now some known vulnerability type updates become a business as usual activity in order to communicate to those that need to know. Sound interesting? Okay, hang around. So I've hopefully at least got some of your attention. It's time to introduce myself and start explaining things. So my name is Chris Nesbitt-Smith. I'm currently an instructor for LearnK8 and also Control Plane, consultant currently to the Crown Prosecution Service, and a tinkerer of open source stuff in this sort of space. I spent a fair chunk of my professional career now working in UK government and large organisations where problems like these are rife. We should hopefully have some time at the end for questions. If not, you can probably find me on LinkedIn somewhere. So, given I've got the luxury of a live audience, albeit you're kind of away somewhere, I wonder if you could put in the comments who's with my CIO and has set, written, or applied some policy before. So just leave a comment and say that you're a policy maker if you've set or applied any sort of policy before. So if that is like, let's say, setting some coding standards for your team, or saying that, I don't know, something needs to be encrypted, or whatever it might be, any sort of policy that you defined, if you could just leave a comment of saying that you're a policy maker. Cool. I'll catch up on whatever everyone's at late in a bit. Okay, so you can next round. So now, if you've sought exemption or consciously bent, broken, circumvented, ignored, bypassed, whatever a policy with at least some good intentions, could you leave a comment of policy breaker? Just leave a comment of policy breaker so I can kind of get a feel for the sort of divide in the room. Cool. Okay, well, if you have, you fell for it. Thanks to the organisers of this event, we've got all your names and your employer's details all recorded. So lend me your ears. The stakes just got raised. So where do I see policy as code going wrong? Well, before we dig into that, what do I mean by policy? So it usually comes in one of two forms. So security enforcing, like data at rest being encrypted, or consistency enforcing, such as code style, so tabs, to or full space indentated maybe. Or maybe you can think of some others, but in any case, it's hopefully intended to mitigate a risk of some sort. However, with the best of intentions, these are often emotionally led rather than being grounded in proportionate control, which there becomes the open doors to case-by-case exemptions being required when you come against situations that you weren't anticipating. So this is not unlike how the laws of the land are created, with case law making for a complex to navigate rulebook and then harder still to measure compliance. It often can look like the thin bit of a wedge where the precedent may have been an uncomfortable pill to swallow the first time round, becomes dangerous with others looking to expand upon its scope, which can lead us to then sometimes wonder if the cure was actually worse than the disease. But that's not at least how we typically develop software. So why does this all have to be so hard? Surely there must be a better answer. Well, we codified everything else. So isn't that the answer? Well, yes, in part, but my point of this talk is that we typically do it wrong. So maybe some of you are screaming your favorite product name at me in your heads as the solution, and I don't think you're wholly wrong. However, the devil's in the detail. Throwing some curly braces or YAML something doesn't actually inherently fix things. So if it's a security control, it's often tempting to just keep that policy a secret. Exposing it could be used against you by an adversary. However, that does not support us in shifting left. It results in devs effectively reverse engineering what the policy is by finding out when we smash our heads up against it. Therefore, it doesn't take much imagination to see in the scenario of an application deploy, midway through finding one resource is non-compliant and rejected could leave the overall deploy in an inconsistent halfway state, likely resulting in some downtime. Which begs the question of, was that policy better than the downtime? Especially if it leads your engineers, who are all hopefully plenty smart people, finding inventive, shall we say, ways around the computer says no response that they've got. This is then becomes further exacerbated when updates to the policy are designed. So maybe you get a pen test or something goes wrong. So you form that case law and you need to apply a new policy. So maybe all S3 buckets now need to be encrypted, a change that could be considered a breaking one. Sure, you might say that you provide warnings on at least the less important or new emerging policy, which is great, so long as someone sees them. So, but if you adopted GitOps or at least CI/CD, is anyone actually seeing those warnings? I mean, who studies the results of a successful build log every time? Anyone? Every time? Well, if you are, I'd politely suggest that you're probably missing the point of CI/CD. You should be able to trust your job status. Okay, well, I'm not here just to throw stones today. So if we remember my implied promises to my 4 imaginary friends of what this future kind of promised land might look like, well, there's nothing new under the sun. We've actually already unwittingly solved most, if not all, of these problems elsewhere. We just need to be reminded and then join the dots. So, well, the first is something that if you're doing policy as code, you're probably already doing. So put it in version control. The thing you might not be doing, however, is then making that visible. So at least in a source it, by which I mean allow your walled garden of employees, suppliers, etc., to be able to see the policy. I'm not saying give away all your threat monitoring and intel away. You can probably keep all of that to yourself. But I'd argue that the visible policy and the gaps therein is often better than the downtime and reverse engineered workarounds and opaque legacy exemption spaghetti soup. So if you're brave, you might even open source it. You'll find that it unlocks an ability to work well with prospective suppliers without NDAs and whatnot, and widely distributed secrets are expensive to maintain, difficult to handle, and then often only stay secret for so long after all. Okay, so we're off to a good start. Our policy is visible now to those that need to see it. So many of you, and no doubt you're used to semantic version, but a quick recap in context to this. So the first segment is to indicate break, perhaps conflicting changes. In the context of policy, let's say it's requiring resources to have a department label. Maybe that will help with some internal cross-charging. Who knows? I'm not really judging. And increments of that might look like requiring that to be from a predetermined list rather than just free text. The second segment is to indicate minor changes. So these shouldn't break anyone. And increments of that might look like correcting a spelling mistake on the department name. The third segment is to indicate patch changes. So these should be a no-brainer for anyone to keep up to date with. And increments of that might look like adding a department to the available options. Okay, so our policy is visible in a repo, its version. We can easily communicate the policy. We can tack on release notes, and expectations are all being managed by semantic versioning. In software, we're used to handling dependencies. So what if your policy was just yet another dependency? You might unwittingly already be doing this if, for example, you have, say, ESLint as a dependency in your JavaScript package, perhaps. Okay, so it's visible in a repo, its version. We can easily communicate it. We can tack on the release notes. Expectations are all set by Assembler. It's beginning to look a lot more like software. Okay, I know testing is a dirty word, but in order to make this an asset that everyone can depend upon, it's also provide known good examples. Tests are essential to give everyone confidence in the stability and surface potential side effects before they can then hurt everyone involved. So consumers of this policy can then test themselves against their policy locally and then in the CD. thus shortening the feedback loop and better informing them. So as a bonus, we should be able to find our consumers able to rely on the artifact that we're sharing with them. Well, we're well and truly on the home stretch. It's a dependency, so updating it should be no different to any other. We can even use some magic like GitHub's Dependabot or Men's Renovate to do this for us. So think automatic pull requests, tests, even auto merging if you like. Okay, so to check everyone is all still awake, can anyone leave me a comment and tell me a recent event that caused people to want to know what version of a certain logging Java doohickey you were potentially running literally everywhere in the estate? Yep, as you know, all presentations this year are contractually required to reference log4j, even when it's almost entirely out of context, and include some memes. So in just a few short months, I can remove these and hopefully just point broadly at a list of scary-looking CVEs in order to command your behavior through fear. What I'm getting at here, though, is that the situational awareness piece around the software supply chain is something that your organization is hopefully already thinking about, if not already addressing. So if our policy is a dependency, this is at least not a new problem. So software bill of materials for the win, right? Which can then lead us to allow us to measure the compliance across the estate. Okay, so I've just covered a lot of ground and hopefully sounded at least vaguely convincing. And this is not just a fictional utopia painted in PowerPoint. It's time to look at actually how you might be able to do this. And I know you all really came here wanting to see a million words on a slide and not just the odd emoji or two. So we've reached the point where I get to show you some code. Hooray! But to maintain scope, I'm going to have to be talking about two things to prove that it's not just one tech or one tool. So I've arbitrarily picked Terraform and Kubernetes, but I could have probably picked anything. Naturally, I'll need some tools to go along with this. I'm too lazy to really invent much here. So likewise, I'm going to pick two tools. But again, I could use any, some, or even all. So Checkov will be doing my Terraform and Caverno will be doing my Kubernetes. If you want to browse along with me, I've created an example GitHub organization here. I'm not expecting you necessarily to read or grok the code on screen. Don't worry about it too much. It's just to prove that it's a real thing. So the policy is stored here in this repo. So here's where my policy starts at v1.00. So I've got policy that requires a department label on all resources. So long as it's set, doesn't actually matter what it is. I've written tests for this. So note how the passing test cases are usable as a great example about what and bad looks like. We pushed a tag in Git. We've added release notes. I can sign it to provide further assurance if my heart so desires, which of course it does. But moving on. Version 2 looks similar, only now that department field has to be from a predetermined list. So, like before, tests exist, release notes are written, tags are signed. 210 is where we notice and correct a spelling mistake of one of the options in the list of departments. 211, and I've now added a new department to the list. App1, so a few more repos in that organization. So App1 and Infra1, well, they depend on version 1.0 of the policy, and it's not compliant with version 2 or beyond. But how do I know this? So I configured Renovate in this case to be automatically make me a pull request. And when there's a new version of the policy, it's super obvious. So if I can update my dependency, and I can also see clear feedback about where and why I'm not compliant. I can also see all the pull requests over the org. So I could use this to measure compliance of my policy. Okay, moving on. So App2, a couple more repos, App2 and Infra2, well, they depend on version 2.00 of the policy. But however, I could merge the open, excuse me, the open pull request all the way up to 211. Sorry, cold. Finally, App3 and Infra3 are dependent on 211, and they get a gold star from the CIO. Okay, there is a small touch of magic to this, and it's not pretty. I've written some bash. Don't judge me, even though I probably will definitely written worse. So what this does is allows me from my dev laptop or in CI to evaluate my code against the version of the policy. So ideally, this might be less cumbersome, but it is what it is for now. Pull requests are all very welcome. And the last piece of the puzzle is managing the life cycle of the policies and allowing multiple versions of the policy to be accepted and evaluated within a single runtime. I've cheated a bit here. Kubernetes gives you admission controllers, so it's not so easy to get the same policy evaluation in cloud. They've got their own kind of policy code and in execution environments. I've not figured out how to evaluate that code locally. Again, pull requests and contribution, collaboration, all very welcome. So you may have noticed the way that I wrote the policy. It's designed and distributed. It lends itself well to coexist with itself in a Kubernetes cluster. Which brings us to a few more repos. So there's cluster 1, which describes a cluster that accepts all the versions that we've described so far. Likewise, cluster 2 only accepts 2.00 and greater. So we can automate all of this using Kind for CI to deploy the apps. And then we have it, a full org, all done, all compliant, policy, all versions, CIO, all aware of what's going on. So this is great. But just one more thing. Wouldn't it be awesome if the policy carried a story about why it exists? After all, if your agile team is even half effective, it will reject anything it perceives as friction if it doesn't see the value in it. It could allow our devs to know why they're compliant. And if they want to do something outside of what the policy permits, they don't need any sort of exemption granted per se. They can have a well-reasoned and informed debate with rationale behind a pull request to the policy. So imagine, if you will, this going through a stage of versions with risks that inform mitigations manifested as policy, all maintained as one. So when the risk landscape changes, your policy can move with it. When some new privacy regulation comes out, say, or your latest marketing strategy pays off, or you acquire more data, for example, even if your policy was perfect at one time, the risks and the appetite will stand still for no one. So we can liken this to over-provisioning that we might be familiar with from elsewhere, where lead times are long, change is hard, and there is a significant pressure in nailing it first time, which can lead us to hedging bets against what some future state might be, rather than proportionate mitigation to the risks that are more tangibly real in the now. So that's where the real culture change is needed. And the execution of that is a long series of talks in of itself. So now this is all really over to you. Honestly, the best thing you could do right now is tell me that it's madness, already done, irrelevant, or otherwise unachievable, something my esteemed echo chamber peers have yet to do. So beyond making pull requests and developing the theory more, I'd really like to start building more case studies with willing organizations and allow me to swap out some of my imaginary friends for real ones. But the most important thing that I want you to remember from our time together is, and feel free to say this out loud with me, that purposeless policy is potentially practically pointless policy, which I've been practicing saying far too many times. So I've been Chris Nesbitt-Smith. Thank you so much for your time. You're now free to leave. I will destroy the evidence of your guilt admissions earlier, maybe. Like, subscribe, whatever the kids do on LinkedIn, GitHub, and you can be rest assured that there'll be no spam or much content at all, since I'm awful at any sort of self-promotion, especially on social media. So cns.me actually just points to my LinkedIn. Talks.cns.me contains this and other talks, and they're all open source. And I've probably definitely run over. Sorry.
Thanks,
Okay,
Chris.
no worries.
You win the prize for today's most slides in a single presentation award.
I mean, we
don't have time for any questions on this one, I'm afraid. But if you want to hang out in the Discord, Chris, I'm sure there's some folks who might want to have further discussions about this, because there's been a lot of folks saying they've really enjoyed it.
Cool.
Okay,
awesome. Thanks a lot.
Thanks, Chris. Right.
Let's bring Mario on the screen like right away, because we are already over time. Hi, Mario, how are you?
Hi, good morning or good lunchtime or whatever. I'm okay. I'm a bit cold, so I'm wearing a big hoodie, and maybe I can get some time in.
Do you? I see your slides already here, so let me put them onto the screen, and we'll give you the show. We'll give you the stage right away. So
yeah, okay. Give me a second. So here we go.
Oh, there was Chris's one. Let me.
Right.
Yes, we have them on, and the show is yours. Go ahead.
No, we don't. That's Chris's ones, isn't it?
Oh,
those ones. I just put them on.
Yes.
Who's pressing the buttons here?
I'm sorry. I was pressing the button twice. Go ahead.
So everything good, right?
Absolutely. Go ahead. We have
Excellent. So, hi everyone. For the next, let's say, 20 minutes, maybe it's only 17 minutes, I'm going to talk about how you can continuously test and security test your open API based microservices when they are deployed on Kubernetes with a cool technology combo. I think this is a really cool combo with a tool called TestCube that allows you to run the tests inside of your cluster, and a tool called Zap, that's a Z-Attack proxy that is capable to run vulnerability scans, so dynamic scans onto deployed microservices. So quick intro on myself. My name is Leander, principal software architect. I work for a German company called QAware. Our headquarters in Munich. I'm sitting in the very south of Germany. Almost, you see down there, those are the Alps. It started snowing today, so it's really cold right now in this room where I'm sitting. I'm responsible for many big projects in our company, for many customer projects. We do individual software development, for example, for BMW, so that large car manufacturer in Munich. And well, security is something that should be really important, right? In 2022, we had quite a few incidents over the last months where it kind of struck us and we had to react really quickly. But to tell you the truth, even though we had those incidents, I still think that holistic security in software development still seems to be a bit of a neglected non-functional requirement in many projects and many agile teams. I do consultancy a lot. I see a lot of customer projects out there, and yes, the developers are kind of aware that security is important, but for some reason they don't do anything against it. So let's try to find out why that maybe is the case. And well, this slide you probably have seen or in other talks. So there's an ISO norm 25010. It's about software product quality, and in that ISO norm there are a lot of entities, right? Maintainability, efficiency, functional suitability, usability, reliability, portability, compatibility, and security, and maybe a few other entities already missing: operability or observability, things like this, right? More modern entities. So the thing is that security is unfortunately one of those several software product qualities. And well, as a team and maybe as a product owner, you always kind of have to decide which one is more important. And for some reason, right, I don't want to judge that, but many product owners, for example, they think functional suitability is definitely more important, right? They want to have the proper and correct and appropriate and complete software product. That's their main focus. And if you would ask a software administrator or an ops person, then maybe reliability and efficiency is maybe in their prime scope. So I think it's usually dependent on who you ask, which of those software qualities gets the most attention, right? And security is kind of a feature, right? I mean, security is also important for the product owner and also for ops people. But for some reason, right, this is a lot of work involved here. You need to do a lot of testing. You need to do a lot of security testing, a lot of acceptance testing for the functional suitability. For reliability, you maybe need to do chaos testing. For maintainability, you need to do software code quality testing. So this is a lot of work, and well, unfortunately, security usually comes a bit short, and that is, that is sad. That is a tragedy. Then I'm really sure you have probably read that book here, the Accelerate book, where they kind of argue that what you need to do for continuous delivery, and on the right hand side you see all those benefits of continuous delivery, low risk releases. Yes, we all want them, and less rework, and we want happy teams because happy teams produce better products, and we want fast time to market and lower cost and happy users in the end. But as it's always said, nothing is for free. You have to do a lot of things to get there. There are a lot of tools and techniques and technologies and paradigms and whatever that your teams need to cater for. They need to handle those things. Loosely coupled architectures, aka microservices. They need to write maintainable code. You need empowered teams. That is a topic on its own. Continuous security from day one, it says in the book, right? So it starts with the requirements, the security requirements. You need to do secure coding, and you need to incorporate security into your daily into this software product delivery chain, if you would like. Test automation is important, continuous integration, GitOps, deployment automation, monitoring and alerting is so much to do, okay? And I think a lot of the teams out there, they're just overwhelmed. This topic of cognitive load, they're just overwhelmed with all the stuff they have to do. And, the hard parts usually are then the ones that are kind of probably neglected, right? And let's see how we can kind of get out of this dilemma. Now, what many teams now do is, what do they do to kind of automate things? Well, they build pipelines, right? We have those CI/CD pipelines. I mean, that is kind of an era on its own, doing like two things. CI is something different to CD, but nevertheless, we always talk about CD pipelines. And what I see out there is that many teams, they start to build those monolithic kind of linear CI/CD pipeline, but they're super suboptimal, and they will result in delayed feedback and long release cycles, and all those good tests, right? The security tests, those dynamic tests, the performance tests, the acceptance tests, they're kind of super late in those pipelines. They are usually reside in kind of flaky pipelines, in long-running pipelines. So what do people do? Well, let's not integrate it into the pipeline. Let's take it out. Big promise. We will do it at the end of the sprint or at the end of the release. Then we do our security tests. But guess what? Then usually they are forgotten, and well, they're not run those tests. So I had that idea. So how can we improve on that? If it's not such a good idea to put these into those pipelines, well, let's see how we can kind of let those tests run. And the simple question is, why should we let those non-functional tests, or in our case today, the security tests, why couldn't we run those continuously, or maybe event triggered based on deployment events on the cluster itself, so that my CI/CD pipelines, they don't have to run the tests. And instead, it's the cluster itself that runs those tests always when things changes, or maybe on a cron basis, maybe every 2 minutes, maybe every 5 minutes, so kind of continuously. Or as I said, triggered by some event, by the deployment event, by your GitOps tool maybe, or by Kubernetes events itself. I want to introduce you to something what I call the digital product assembly line, right? I worked for the last 14 years in kind of different projects in the automotive context, and if you've been in one of those factories, everything is super automated, right? The chassis comes, and then all those robot arms, plug in the engine and the wiring, and they paint it, and the windows and all that. And I think software engineering should be, or software product development, digital software product development should be as automated as possible as these factory assembly lines. So here's my pitch. Okay, so let's split things up. How would the conceptual architecture of such a product assembly line look like? Like, this here is not something new, hopefully, right? I mean, we have devs, they write code, they push code into Git repository. Then I have some form of CI pipeline, maybe GitHub Actions, or maybe a good old Jenkins or something that does the checkout, that then maybe, or that does the build, maybe with Maven or Gradle in a Java world. You have some unit tests, some early unit tests, maybe you have some early test container tests. You do some static code analysis, maybe using SonarQube. At that stage, you could already incorporate static security analysis tools. There are lots and lots out there. At the end, you have then the final packaging phase, where you package up all your artifacts that you just built into a nice, cuddly Docker image. And then the next phase is, well, you publish that Docker image to some repository, right? GitHub Packages, or Amazon ECR, maybe a Nexus repository, something you like. Again, here, you could have some tool already in place that maybe then already scanned the Docker image for, known vulnerabilities and all that. Right, so far so good, nothing new probably. Then you have, or you should have, we've seen in the book, you should have some GitOps workflow running. So either you prefer Argo or you prefer Flux. Today I show you Flux, or I use Flux. Flux will watch first up for a GitOps repository to know what has changed, what needs to be deployed on the cluster. Flux can also watch on the package repository. When there is a new image, Flux will also already update those manifests, and then finally deploy something to the cluster. So now I have something deployed. Now I have that event I talked about before, when I can now kick off those fancy performance tests or acceptance tests, or in our case, security tests. And this is basically what I will show you right now in a small demo and with a few details. So I said before, two really cool tools. The other was Z-Attack Proxy, called Zap, and TestCube. So let's see. Now, everything I show you is in that demo repository here, which is my private GitHub repo, TestCube Zap demo. Fork it. Please feel free to use anything you like in there. It's MIT license, so copy and off you go. So quickly, overstep attack proxy. Well, I think it's pretty widespread and it's well known. It's an open source vulnerability scanner, super good documentation, international community, vivid community, still actively developed. ZAP provides several modes of operations. You have an intercepting proxy. You can do active and passive scanning. You can do an HTTP spider to kind of crawl a website. You can use a brute force scanner, a port scanner. Relevant for today is you can scan and then attack open API v3 endpoints, so good old REST endpoints. It even has support for SOAP and GraphQL, where SOAP is kind of the old style, GraphQL maybe the new style, and also WebSockets. What's really cool about ZAP, it has a really powerful API and a few tools that allow you to automate the security scanning, right? So that you don't have to click anything. So the automation is done by a few scripts in the one place, and they also have a few language bindings like a Java binding where you can interact with ZAP programmatically. Now, the cool thing for a containerized runtime environment is that ZAP provides an official Docker image that has everything baked in. Okay, so you only need that one image. And with that one image, you can do API scanning, you can do baseline scanning, you can do full scanning, active and passive with AJAX scanning. So in case you have kind of a web page, but the API scanning is really relevant for today. You even have a web swing UI if you want to have a fancy UI that you can click. Now let's quickly jump in one of those. Where is that UI I want to show you? So this here is kind of the web swing UI I just talked about before. So this is the basic ZAP UI. You could also install locally on your desktop machine, right? Basically, it's a Java program. But this now runs in a browser, and the deployed UI is already running in a Kubernetes cluster I just spun up, a few hours ago in the Google Cloud. And up here, for example, you have something called import open API definition from a URL. And now let's see. So that is the URL I will point in here, and you see that's a microservice default service cluster local. So that's the DNS name of a service inside my Kubernetes cluster, port 8080 open, where the open API definition comes from. And down here, we override that one. And just to show you, this is then you press import, and now he does the scanning. And now ZAP already discovered all the endpoints that my microservice is offering. Okay, and I know I show you this manually now, but everything I do here can basically be automated. Okay, so this is just to show you what I'm automating in like a minute time. So here, and basically what we can then now do is we can say attack, active scan, and off you go, start scanning, and now ZAP will attack my microservice deployed in my cluster. Okay. So let's see how we can kind of automate things. Well, option number one is we could program something, and option number two is we could use TestCube to kind of do the job for us. So the automation, just to be complete, well, this is, for example, a Spock spec. So everything I just showed you in the UI can basically be done using that way here. So this is here, I create a new ZAP session. I say import URL, and down here, I say I want the API minimal scanning, and then I scan each of the URLs discovered in the previous step. So this is how you could kind of code your vulnerability scan using ZAP. All you need is kind of this either the ZAP daemon. This is here the Docker image I told you before. So this is kind of a headless daemon deployed where only the API is spun up, and my unit test or unit security test will then contact that daemon, and then the daemon will kind of do the scanning and the attacking of the microservice deployed in the same cluster. And that is kind of the deployment or the part of the UI I just showed you. Okay, so it's a bit of Kubernetes YAML, no big deal. Deploy that to your cluster, off you go, and you have ZAP running inside your cluster, and you can automate it from the outside if you have kind of a unit test. Okay. So okay, get NS. So this is here, for example, this is all the namespaces on my cluster. You see the ZAP stuff is deployed in ZAP, and now you see here, that namespace is called TestCube. So let's quickly talk about TestCube. What the hell is TestCube now? Well, TestCube now is kind of a cloud-native testing framework for Kubernetes, okay? So TestCube integrates this test orchestration and the test execution into your Kubernetes cluster, okay? And it takes it out of your CI/CD pipeline or the GitOps pipeline, okay? So you don't have any vendor login for test orchestration and execution anymore. So TestCube is completely decoupled from your Jenkins, from your GitHub Actions, from your GitLab Actions, whatever CI system you use. But the cool thing is that it kind of decouples the test execution from the build process, okay? This is two things. Build process is one thing, do one thing well, and then comes the test execution. It also enables your test engineers, if you have some, to run specific tests whenever they need them. Now, TestCube makes it really easy to run those non-functional tests like, load performance tests and security tests and compliance tests within your cluster, okay? And that is really cool in highly constrained environments where maybe the cluster is not even accessible from the outside. So all you need to code is your test, and then you tell TestCube, hey, TestCube, here is a ZEP test, or here's a K6 load test. Please execute that whenever something changes in the cluster. It's kind of a modular architecture, and for each and every test it supports, they have a concept called the executor. So what I will show you is kind of this here, okay? So that's kind of the demo architecture of the cluster I'm currently running. So I have TestCube deployed inside my cluster, inside a dedicated namespace in the cluster. I did the deployment using Flux, right? So also the TestCube deployment and lifecycle is managed via GitOps. It's a simple Helm chart. You can deploy in a cluster. Then you have a nice fancy dashboard, for example. You have something called the API server that you can interact with as a developer using the CLI, for example. You could also have a CI system trigger the API server to start with the test phase. The really important part are the executors, right? So for each and every certain test type, you have a distinct executor, like a ZEP executor or a Gradle executor or a K6 executor. And you declaratively define your test. So good old Kubernetes style YAML. Obviously, all those manifests can also be managed by GitOps. So test is kind of the smallest piece bit. Test can reference test sources. A test source is something like a Git repository, for example. You have test suites. Test suites aggregate individual tests, and you have test triggers that kind of are then the glue. Whenever a deployment changes, then run the following test. So let's dive into that demo here a bit more. So we kill that one here. So what does a ZEP test look like, the TestCube style? So to just give you an idea. So this here is basically tells, hey, dear TestCube, this is a test, follow the following name, add the namespace TestCube, type ZEP API, and then here in the data, what you need to specify is a few configuration parameters. This is basically all the parameters you could set in the UI. So maybe you remember, and this link I just inserted into this UI field. This is basically all the configuration that the test needs in here. So what you can then do is, for example, so to create that test, either you write that piece of YAML here and commit it to your GitOps workflow. Obviously, there's a nice cool CLI you could also use to do exactly the same. Let's see what we have that one down here. For example, you say, so the CLI comes as a kubectl plugin. So you say kubectl TestCube create test, test2, bam. So that one is now created. And if you would want to run that ZEP test, then, well, basically what you could either do here, down here, is you say kubectl run test. We do that, like that, watch ZEP API test, and then this will, start running. So that obviously now takes a while to spin up. We only have 2 minutes left, so I need to speed up a bit. So it's super easy to kind of tell TestCube now, hey, listen, with the following configuration, now do your testing. And now comes the final tricky bit. So this is this here, okay? So this is a so-called test trigger, okay? So this basically says, whenever there's a deployment in the namespace default that has the following labels like app microservice, so this is my small Java-based microservice. In case of a modified event, then please run the following test with the name with the name what we just specified. So we just changed those names here. So what we could do now is either apply that manually or have GitOps apply the stuff as well. So what we could do is kubectl apply -f. Okay, it's S test kube, and then we have the ZEP API test trigger. So now, test kube will watch for any change events on my microservice, and whenever my GitOps workflow now deploys, or those other pipelines deploy the microservice, then test kube will automatically trigger the ZEP test once the deployment has changed. So every time something changes, I let the test run. There is also the possibility to let the test run using kind of a cron scheduled type test. Right. So I hope you believe me that this is a cool tech combo to kind of continuously let those those penetration tests onto your microservices run continuously on your cluster, and pull those out of the CI pipelines, and let the cluster do the work so that you don't have to do the work, and that hopefully you ship nice and secure microservices out there for your customers. All right, that's it. 20 past 1. Thanks for your time.
Awesome. Thank you, Mario-Leander. I really love that. That's super cool. Again, we're slightly running behind again. So if folks have additional questions, I'm sure you'll hang around in Discord for a few minutes and just see who's got questions for you.
Let's get our next speakers in. So let's welcome Dolis and Anusha. Welcome.
Hey, folks.
Hello, you are on screen. Good to have you.
Thank you.
All right.
Good to be here.
I understand that we have 2 slide decks, and I will start with Dolis' slide deck or Dolis' screen. Correct?
Sure.
So we already running out of time, so I will not do some chit chat. I will just give you the floor, share the screen, and you two go ahead, and we will remove ourselves because you are way more interesting. Let's go ahead. Cheers.
Thank you. Hey, so welcome everyone. Welcome to our talk, Securing Kubernetes Manifest with Cosine and Kyverno. I'm Anusha. I'm a technical product manager at Nirmata.
Hi everyone, thank you for joining. My name is Dolis and I'm a customer success engineer in Nirmata. So today we are going to talk about how we can secure your Kubernetes manifest with Cosine and Kyverno. And these are a couple of the agendas or talk topics that we are going to cover in today's session. To start with, we will talk about what does a Kubernetes CI/CD workflow looks like in the Kubernetes world, or how different people are using CI/CD pipeline with different tools, and then why we need to sign anything. Where does signing and verify fits in entire these pipeline, and how can we sign and verify the container image? What are some of the projects and how they can help you? Along with that, Anusha will talk about a little best practices, and then we'll end up this presentation with a quick demo. So starting with what does Kubernetes CI/CD pipeline looks like, you will see that this is what the CI/CD pipeline looks like today, which is nothing but a different stages tools used. So we usually there are different tools that are being used at each level, starting from storing the code in the repository to building and testing it. And then these all codes or these all build things are then consumed by your consumer. Now, with advanced technologies like containerization and Kubernetes, it makes it more complicated. Ensuring that you have the right security practice followed is often challenging. So once we have this pipeline, which we are aware of, how does it look? Why should we sign anything? And why should we even sign anything in, like, if we think about this, if we forget about the software for a moment and generally think about why we use signature, we will know that how important it is and why it is so necessary to provide trust into any process. So which narrows down to 3 things. That is, signing anything provides authenticity. So where you can make sure that whether the data or payload which you are pulling is coming from an authentic source. It gives you that trust that, okay, the data is coming from an authentic source. It provides you integrity, where you can make sure that the data is not tampered in between, and you can actually rely on the integrity of it. And finally, you can make sure that once you have sign anything, you can just not go back and you can change anything and come back. So changes like that can be, the updates or changes like that can be cannot happen once you sign anything. And in today's cloud native world, where a simple unit to start with is we all start with building an image. So all we do is first we start building an image where we have all the dependencies and several other things we use to build that. Now, when we are using that image in our Kubernetes cluster, we are not only depending or relying on that image, but we are also trusting it. And not only that image, but we are also trusting the base image and all the code that it is included. Now, how do you make sure that the container image that you are running is authentic? If you think that the right tag will be enough to make sure you're using the right image, let me tell you, it is relatively easy to override a container registry or trick the system to think it is using the right image, whereas it is not. So that's where signing an image and even signing a YAML and verifying the same will help. With the help of some of the policies, will help you to enable the right check at your security system or at your entire CI/CD pipeline. So we understand why we need to sign anything. But how do you sign anything? What are the different ways you can sign anything? So what we can do is the publishers or the artifact publishers can actually create a key pair, and you can use a private key to sign your images. You can then distribute a public key for your consumers, and the consumers can use this public key and actually authenticate whether the signed image is verified or not. Now, unfortunately, when you add these pieces, it's often hard to put together that we think it is. So that's where Sigstore helps. Sigstore is a set of open source project for signing and verifying and protecting your software. So where cosign is a sub project which is specially targeted as signing and verifying a container image. It includes cosign project to sign image and verify image. And it also encapsulates some of the logics specific to YAML and image signing and verification. So what you can do is, or what exactly, if you think about the CI/CD pipeline, taking a step back, going back into our previous conversation we were having, is what you can do is you can have the cosign CLI to sign your images, and you can sign your images at the start of the pipeline. And what you can do is you can have QAware, which is running in your Kubernetes cluster, which will verify this image and make sure that whatever the images are, they are signed. And it will also block the unauthenticated or unauthorized images. And you can do this not only for the images, you can also do it for the payloads. You can do it for the approvals of the Git commit. You can also do it for the manifest to increase or enhance the security level. So a little bit about QAware. QAware is a Kubernetes native policy engine. It's the policies and reports that QAware deploys are Kubernetes resources. It runs as an admission controller, and it also has a CLI. So you can also use Kubernetes CLI in your pipeline, and you can verify all the deployment before you are deploying it on your Kubernetes cluster. And it also has a background scanner, so you can actually scan all the images that are running on your cluster. So you can scan the background, and QAware can create a report for you, so you can actually see what exactly is happening, what is failing, what are the images that are signed and what are not. Using QAware or using QAware policies, you can verify, mutate, and generate Kubernetes resources. So you can do a couple of things, couple of cool stuff using Kubernetes, using QAware policies. And all of this is in a simple YAML format. So you don't have to learn anything, or you don't have to learn a different language. If you know YAML and Kubernetes, a little bit about conceptually, you know how it works, you should be good to write your policy from day one. And and specifically, this is integrated with Sigstore cosign for image and YAML verification, which Anusha will later talk about and show you a policy. How does it look? And it becomes really easy to actually verify an image, and you don't have to do a lot of things manually, which otherwise is the case. Okay, so I think we are good with why we need it and how we can do that. Now, Anusha will cover some of the best practices and demo you quickly how you can actually sign and verify image in your cluster. Anusha, you're on mute.
Anusha, yeah, that's what I wanted to say. You're on mute, but
Every time. Okay. So yeah, thank you. I'm going to cover a little bit on the best practices that is followed in the industry today. So what does make every phase in the supply chain trustworthy? So this image is taken from a paper that was published by the CNCF tax security team. This paper was published last year. It's a good read. So I've also included the reference link. So do check it out. I particularly like this image because it clearly tells us what is software supply chain. It is analogous to our traditional supply chain, wherein you have a factory wherein you manufacture things, you package, you process, and then finally you ship it to the customer. Similarly, in software, we start with our source code. That is, whenever we write code, we not just write new stuff, we also import libraries so that those become our dependencies. Then we have build systems. So if we have a Docker file, we build a container image, we create all our release manifests, and then we either store it internally for internal consumption or over a network in different repositories. And finally, your consumer, when you have to consume all these artifacts, you pull it from the internet and you deploy it in your target environment. This environment could be the public clouds or on-prem systems, but you have to get all these artifacts from the publisher. So each phase of this supply chain has to be secure. So in the recent past, all of the cyber attacks, if they have taught us anything, is that security should not be an afterthought. Security should be included right from your design phase to your writing the code, to build systems, and finally while deploying. So it has to be part of each and every phase in this supply chain. And also, it is important that all of these steps are automated, because it is not humanly possible for one person or one team to carry out all these steps. That is where there are several open source tools which help in automating different stages of this supply chain and add security to each of these phases. And in the demo today, we are going to look at two popular open source tools like Dolis mentioned. We are going to use Cosign to sign our container image. And then we are going to use QAware to verify that actually the signed image is what we are using in production. So let's quickly jump to the demo. I have a screen recording so that we don't run over time. I'm going to walk you through this recording. So let me start. Yeah, so I have a simple hello.py file that just says hello world. And I have a Docker file that says copy this file and then execute the file. So this is the Cosign public key. So this is the public key that Dolis also mentioned that you need to distribute to your consumers. So using this public key, the consumer will verify that whatever was used to sign the image or an artifact is actually the same. So we can generate keys using Cosign. Here locally I've generate using the generate key pair command, but it is integrated with a lot of things. You can use X509 certificates for signing. You can use AWS KMS and a lot other things. So this is the QAware policy. So there are a few parts in this I'm going to explain about. So this is a cluster policy. It means this policy is applicable throughout your cluster, irrespective of the namespace. And we name this policy check image. And the validation failure action is enforced. It means if there's a policy violation, the admission request is going to get rejected. And then we have kinds. That is, this particular policy is applicable on resource kinds, pods, and deployment. QAware is a policy engine which acts as an admission controller. So whenever you create a new pod or a deployment, this admission controller sees that, okay, this policy is deployed and there's a new incoming pod or a deployment. Does it pass the policy or not? If it passes, it admits the request. If it fails, it rejects the request. And then verify images is the key. So here we are using Cosign for signing the images, and QAware has integration with Cosign. And this is the particular key that you have to use in your policy, verify images. And then you give your image reference. So here I've stored the image in my Docker Hub repository. And this is the public key. So you have to tell your policy what is the public key to use, and it is the same public key that was generated by the cosine key pair generate command. Now let's look at a deployment file. So this is your typical deployment file, and the image that I'm going to deploy in the cluster is the DevSecCon demo image. All right. Now that we have looked at all the files, we will build and push this image. So I'm pushing this to my local Docker Hub repo. Okay. So now let's just quickly verify. We see that the DevSecCon demo is indeed pushed with the tag 100. So now we have our setup ready, but now we need a cluster for it. So for the demo, we are going to create a kind cluster. And when the cluster is ready, we will start deploying policies and see what happens. So the nodes are ready. Kyverno is also available as a Helm chart. So for the demo, we are going to use Helm chart for installing Kyverno. So you add the repo, you update it, and then finally do a Helm install. You can see that I'm installing Kyverno in its own namespace Kyverno. It's a good practice, and setting the replica count to 3. So if you look at the pods in the Kyverno namespace, there should be 3 Kyverno pods. Yep, they're initializing. And once the Kyverno pods are ready, we are good to install the policies now. So just a quick recap of what we are going to install. So if we look at the check image policy, so this is a cluster policy, and it's a DevSecCon demo, it's the correct image tag, and it's an enforce action. And the deployment, just making sure we are using the same image. Now that all the pods are running, we're going to install the policy in the cluster. So you apply the policy YAML. And now the setup is such that we have a kind cluster, we have Kyverno admission controller running, and we have installed our policy. But the image that we have pushed to Docker Hub doesn't have, it's not signed. So, but in our deployment, we are using the same DevSecCon demo 100 tag, but we have a cluster policy saying if the image is not signed, you have to deny the request. So let's try applying our deployment YAML. So typically all the deployment YAMLs, in a production environment, you create a different namespace for that. So we are going to apply this deployment YAML in a prod namespace. So as you can see, Kyverno has denied the request, and the message that we get is it failed to verify image because there are no matching signatures. Now we are going to fix this. We are actually going to sign our image and then push the signature. So remember the cosine.key and cosine.pub that was generated. So we are actually going to make use of cosine.key now. So this is the command to sign your Docker images. So you give the private key and then you give the image name. So that's it. It's a cosine sign command signs the container image, and it also pushes the signature to your Docker repository. Now we'll refresh this to verify the signature is also pushed to the OCI repository. Yes. Now we'll go back and see, try to apply the deployment YAML again. Now all the policies are matching. We have a signature. We are using the image that is signed. So this should work. And yes, we have our deployment that is created. So that is the demo I had. I'm going to quickly switch back. Yes. So yes, so we saw that. So Dolis talked us through why securing images and manifests is important. We looked at the Sixstore project called Cosine and a QAware, which is a CNCF incubating project, even though these are two completely different projects. And that is one of the benefits or advantages of open source, is that all these different projects, when used together, they can provide very powerful features. And how these tools actually complement to achieve a secure software supply chain. And we also looked at some of the best practices. Yeah, and if you want to get started with either of these projects, QAware has a set of sample policies. There are over 200 plus sample policies. You can take a look, and at least some of them should be readily usable for your production scenarios. And if you have any questions, you can join the QAware Slack channel. We are on the Kubernetes Slack and also on the CNCF Slack. Also, you can visit the Sixstore official site to join the Slack channel, and they have a ton of good, cool projects under the Sixstore community. And also, there's a very helpful Slack channel out there. Yeah, thank you.
All right, thank you so much, ladies. This was amazing, and thanks for the demo. That was smooth. I need to do that trick later on. Oh, let me remove your screen right away.
Oh, okay.
No worries. I need to do that trick where I just recorded and that nothing happens, because most of the times
the demo gods are never in my favor. So
most of the time I screw up with live demos. But thank you so much. If you have any questions for both of these ladies, or for one of these ladies, please feel free to put them in the Discord, because we are running a bit over time and I want to bring up the next speaker. So thank you, Anusha. Thank you, Dolis. This was great. Thank you.
Thank you. Bye-bye.
Thank you.
Bye-bye.
Bye-bye.
So next one is Hila. Hey,
Yeah.
Hila, how are you?
I'm good.
Hi.
How are you, Brian and Matt?
We're doing great. I mean, the hard work is done by you folks, and we're just have to be on stage and sometimes introduce somebody, and well, try not to make it too long. That's pretty much my thing. So let me bring up your screen, because I already have it, and I would say the floor is yours. Take it away.
Thanks, guys. I'm
Great.
gonna share my screen in a full screen. Okay, awesome. So first of all, thank you so much for joining this session and DevSecCon in general. And this talk will be about open source, and open source is open choice, right? So in this talk, I will give you a set of tools to help ease your decision about open source adoption, when you should do it, and practical tools that you can use to choose the right open source project for you. So first of all, hi, my name is Hila Fish. I'm a senior DevOps engineer and I work for Wix. I have 15 years of experience in the tech industry. Recently, I've joined the AWS Community Builders Program. I help co-organize conferences in Israel, where I live, DevOps Days Tel Aviv, and StatsCraft Monitoring Conference. I'm a mentor in courses and communities, a great believer in the DevOps DevOps culture. I'm a fan, and I'm a lead singer in a cover band. As you can see this picture, it is a lot of fun. Okay, so open source is publicly available, right? And you can modify it at will. Of course, don't just push to a main, create a PR, you know? And the thing is that a lot of tools that we use in our day-to-day is open source. So React, Java, Firefox, Linux, right? All of these amazing tools are open source, which is awesome to know. So in the late 90s, proprietary software was considered the standard, and the notion of making source code public was considered bad strategy for tech companies. Coming forward to 2020 and up until now, the concept of open source became mainstream. So let's understand what's so good about open source. So open source helps build a rich developer community because it's a society that is based on knowledge, but really relies on the core values of communication and collaboration to succeed. And open source also boosts our code quality and security because, as Linus Torvalds said, no one, right, is just the creator of Linux and Git. So this amazing person said that given enough eyeballs, all bugs are shallow, meaning that if we, since the code is publicly available, anyone can spot and correct any errors or omissions. And if we don't only spot them, but also fix them, then the code will be in a high quality state and much more secure. And open source also boosts adaptivity, because how the code is adaptive, since we have more users, then we have more use cases, and then the code will be much more robust. It also allows us surfacing bugs and edge cases much more rapidly than traditional QA processes. And it also encourages more modularity, avoiding the one-size-fits-all kind of assumption, resulting in a greater flexibility and lower customization costs in the long run. Also, it helps with agility, right? Because most of open source software follows modern software development processes, which leads to rapid development cycles, which leads to more frequent releases without sacrificing quality. Also, we have less bureaucracy, right? Opening a support ticket for proprietary software as opposed to opening a PR, totally two different things. And we have no regularly scheduled release process like other companies will release only on Sundays to not harm the clients. In open source, they just release the versions. You can use them whenever they want, and that's it. And I put an interesting read by Ben Balter. He works for GitHub. I quoted some stuff throughout until now from his article, great article about open source adoption. I really recommend you to read it, and we will provide the link afterwards. So let's cover the DevOps perspective, because usually this is something that is more dealt from the developer side and not DevOps. So I'm gonna share with you the DevOps perspective towards open source. So in order to understand DevOps perspective, let's understand the developer's perspective. So developers say, hey, we care about functionality. And once we find a library that is open source, we need to check how well it will get integrated in my code and what efforts are needed to do so. Maybe I need to do refactoring and stuff like that. As opposed to that, DevOps, our main concern is the environment. So once we find a project that we want to integrate, we say, okay, how well will it get integrated in the environment? And we have other peripheral things to consider, like security, maintenance, etc. Also, a common ground between DevOps and open source is collaboration. And as it says here on the screen, when it comes to challenges, collaboration leads to better conclusions and solutions, because when communities form around shared challenges, the diversity of ideas that naturally emerges surfaces better solutions. And we all want better solutions because I care about the environment, right? And we want to make sure we introduce the best implementation and best solution possible for the environment. We also treat open source as tools, and we ask ourselves, do we want to introduce this and that to the system, things that will help us deliver code or automate this or introduce this capability? And we can really be flexible with what we introduce to our system, since integration is no strange concept for us, because a lot of DevOps engineers came from the system engineering background. So we did a lot of integrations back then. So we just treat it as another tool for our tool chain, and that's basically it. Of course, not everything is good or bright. We need to understand that there are trade-offs that needs to be considered, because we need to care about the environment stability. So we are in a constant state of trade-offs and maintaining balance between, okay, we have a tool and the tool got a new release, but maybe the version itself is not that great for me at the moment, because the features are not really worthwhile, or there's still a big bug that I can't really afford introducing to the environment, and we don't want to rock the boat too much. Also, there's a lot of variety of projects out there, a lot of things to consider, a lot of dependencies, right? A lot of complexities. Take, for example, Jenkins. Show me one person that is able to upgrade Jenkins or its plugins without having any fear that nothing or something will break, right? So we always need to think about what we do and without rocking the boat too much, because our focus is the environment stability. And in the middle of everything, once we get to learn about a certain tool, we need to do some research, because we need to make sure we know exactly what we introduce to our environment. Another thing, this is generally speaking for DevOps, but also for open source, we need to keep tabs and be informed of what's going on, because I really like this picture, because if you closely look, it says keep moving people, even though nobody's there. That's exactly it. We need to keep tabs and be proactive and learn about things on our own without having our team leader breathing down our neck and saying, hey, please check this and that. This will make us better engineers, in my opinion. And I will give you an example for that from the open source perspective. So let's say we found a tool, version 1.0 is okay, but it doesn't really fit our use cases, or there is a big bug that I can't introduce to the environment yet. It's not worth a while yet. So maybe I can keep tabs, follow this project, watch it in GitHub, and then version 2.0 will be exactly what I need. Features are great and suited for my use case. The bug was fixed, all good. So this is one example. Another example is that if you take, for example, CentOS, the operating system, it reached end of life at the end of 2021. For those who don't know, end of life means no more security patches getting released to that operating system, and then it puts my systems at risk. So if I didn't know about that, if I didn't read and check what's going on, then I wouldn't be able to support my systems in the best way possible, and even putting them at risk because of that. So being keeping tabs and being informed of what's going on is very important. So let's understand, when should we consider open source? So when we have an uncommon use case, like, for example, in my previous company, we had a need to decrease pods in Kubernetes to 0 and not to 1. And we used a GKE. At that time, I think it still doesn't support that. We used Hegde. Hegde is an awesome open source tool that allows us to do that. Uncommon use case solved by an open source. That's great. Another reason, when you have limited budget, right? So, and you can't really afford purchasing an enterprise license of the software, then you can use its free version or open source. Also, insufficient in-house resources, ability-wise, like this family guy right here, or capacity-wise to create a solution of your own. And you know, why reinvent the wheel? There's a saying like that. So if there's already a solution out there that fits your needs, just use that. We can discuss the good without discussing the bad. So let's understand some of the disadvantages of adopting open source. So first of all, security by obscurity. This notion doesn't apply on open source because proprietary software companies can claim that their code is much more secure than open source alternatives because of that, because hackers can check the code and spot any loopholes and security breaches. We need to understand that open source does have a tendency to be prone to abuse, because I can give you two examples for that. Colors NPM package, where the maintainer added a loop and created a lot of issues for a lot of companies, and Fakir.js, which the maintainer, if I'm not mistaken, had a bankruptcy, and that just the next version he released was to delete the project in its entirety. So you can say, but yeah, I can put a version in requirements.txt or package lock.json, and that's it. But yeah, but if anyone could have done that, then we wouldn't even be hearing about all of these special cases. So we need to understand that it is prone to abuse, and we need to be aware of that. Compliance, so in its raw form, open source usually gives no warranty or official guarantee, making it difficult to use in a business environment where compliance is a must. Open source is not always free. We need to learn that. We need to check the licenses very carefully, especially if the reason for choosing open source is because of you have a limited budget. Discontinued projects. Not all open source projects are backed up by companies. Some maintained by people like me and you, and they are totally in their right to say, hey, I'm not supporting this project anymore. It's okay. So if this happens and you adopted a tool like that, it means that you either need to do a migration to another tool or another solution, or you'll be the maintainers from now on. Support is not guaranteed, so you need to assume good faith when you deal with open source. I opened the issues to get Hegde in very out of business hours, and they were very, very helpful. So you need to assume good faith. And if you do, and if you explain the situation very nicely, they should be able to help, because collaboration is a common ground. And SaaS alternatives, it's not really the opposite of open source, but since a lot of companies shift more and more resources to the cloud, we might see more managed services adoption rather than open source, because they prefer to shift the center of things from a dependency on DevOps teams as opposed to being a cloud lock scenario. So we need to also think about that. So to sum things up in regards to adopting open source, there really don't no right or wrong. It's a matter of perspective, and there are multiple factors to consider, and we should use and we should choose what's best for our needs. And speaking of our needs, how do we choose an open source project? So there are a lot of questions that I have here listed. I don't have much time, so I'm gonna speed right into it. So popularity, check GitHub stars, check if the project is part of CNCF or incubator, because if so, it's a good stamp that it has it is in a high quality state and high standards. Google the project alone to check for online presence, but also Google it versus similar products to check for reviews, and maybe stuff will rise there that is not in the documentation. Activity, check the commits rate. Are they daily, weekly, monthly? How many issues are there? How many releases are there? Is the project maintained by one developer or more? Does the project have sponsors? All of these questions are meant for you to understand that if you need like day-to-day maintenance or somewhat day-to-day, if you need bug fixes or releases, how long should you wait for them to come out? Security, you need to check for known vulnerabilities and supply chain considerations. It's less something that is visible in the DevOps realm, because usually we use projects and not libraries that we incorporate in code, but still security is always something that we need to consider, so always have that in mind. Readiness, is the project declared as production ready? Keda, the tool that I mentioned, is production ready, which is awesome for me as the production gatekeeper. Are the current features enough to sustain usage? And is my use case covered fully in the current state? And if not, am I okay with it? Because if not, maybe I should keep tabs and check the next version that will come out. Documentation. So documentation is probably the gateway to the project, and this is how we learn things about the project. So if the documentation is rich and covers most aspects, like how to integrate, known issues, explanations about features, etc., then it will really help us understand both how to integrate, but also understand if this product is what we actually need, if it fits our use case. Ecosystem, I think this is the most important metric out there, because I will give you an example. In one of my previous companies, I used Rundeck for the CI tool. At that time, the documentation wasn't great and the ecosystem was very, very small. So it was very hard to learn how to do things. As opposed to that, in other company, I used Jenkins. You can say a lot of things about Jenkins, but the ecosystem is very, very large. And it's not only the fact that people can help you if you reach out to them, it's the fact that if you know that a lot of people are using it, probably it's suitable for a lot of use cases. So ecosystem is the metric that will help you in your day-to-day, making it much more easier to maintain rather than not. Ease of use, do a POC, see how well it gets integrated in your environment, and check the issues on GitHub. Are the issues about features or about how do I do X? Because if the issues are about how do I do X, probably it's not that easy to use. And check roadmap. So if the project is planned to stay open source or be monetized, and also features planning. If they think about the features plan ahead, then there's a future to that project. So to sum things up, how to choose an open source project: ask the general questions to cover the basics, to check if the project is in a ready enough state, and ask the tailored specific questions to cover your use case and pain points. So if, for example, you have a heavy use case, put more weight on the documentation and ecosystem metrics. If you don't have capacity for maintenance, then put the emphasis on readiness and ease of use metrics. Do a POC and rely on your research, ecosystem to the rescue, and also engage in GitHub, open issues, and contribute to the project success. And usually I have another slide of how to contribute to open source without writing a single line of code, because you don't have the time to do it or you don't have the ability to do it. But I'm already over time, so I'll just leave you to it and read this. And if you have any more questions, I'm here. Thank you so much.
Thank you, Hila.
Thank you, Hila. That's great. We're massive fans of open source here, so preaching to the converted.
Absolutely. I just wanted to call out one comment in the chat that you were talking about the downsides of open source, and so most of these or some of these things might also be applicable to proprietary software. What are your thoughts on that?
I mean, depends on what. For example, in terms of support, for example, they do have guaranteed support. I usually, when I have more time, I say and kid that maybe the support is guaranteed, but it's not guaranteed to be good. So
absolutely. Oh yeah, 100%.
They do have a support which is guaranteed. So it really depends on which level, and sometimes it will be much more easier or at least official on the proprietary software, as opposed to open source, where everything you need to assume good faith and just hope that everything will sort out.
Yeah, absolutely. One thing you can do is also commit to the open source project you are using. So that might help actually solve your problem yourself. Thank you so much. If you have any more questions for Hila, feel free to join our Discord and ask questions there. But we are moving on to the next one. So thank you, Hila, and I see you next week in Tel Aviv. Absolutely. Bye.
Bye.
Oh, we're pushing the buttons both again. So,
I'm pushing the buttons.
You're pushing the button. Let's bring Chris on. So, Chris.
Hey, Chris.
Welcome.
Hey, how's it going? Glad to be here.
All great here. All good. Hope you are ready. So let's pop up your screen. I have it here in the back. Great. And I would just simply say the floor is yours. Hit it.
Hey, how's it going? Chris Russell. I'm going to be doing a talk here called AppSec for Everyone. This is really kind of just a foundational base kind of talk on some of the best practices, some of the pitfalls, some of the ways to get things off the ground for leaders and some of the other non-technical stakeholders. So right off the bat, here's the contents of what we'll be going through. Why AppSec, components, evolution, trends, best practices, pitfalls, conclusions, and the questions. Right off the bat, why AppSec? Now you're on this, you're on this stream, so obviously you know something about AppSec, you know something about DevSecOps, it's an interest of yours. But let's really talk about like why this is exploding right now. Previously, there was a small amount of organizations that were in AppSec or developing apps at all. It was just Silicon Valley type companies, but now we're seeing this kind of everywhere. And now that all organizations are dealing with apps and different things to support their services, this introduces a host of different security issues and things that people can consider. So AppSec, we're taking best practices, security software, hardware techniques, putting this all together, try and protect their computers from any sort of external threats. Any sort of insecure application can be exploited fraudulently. This can lead to data infiltration or exfiltration, financial, crypto exfiltration, proprietary data being stolen, customer data, PII, all the things that we want to avoid and we're trying to protect against. I'm also kind of feel like fraud and cybersecurity kind of come together in this regard. These things have previously been very distinguished enough in organizations, and I'm seeing fraud teams and infosec teams in regards to AppSec having to work a little bit closer together because of the fraud aspect of it. Now, like I was saying before, everyone's got an app now. Even if you have a toaster, they're going to give you an app as a a support service. You can do it from bed or whatnot. So we're seeing just an explosion of companies that have never been in apps before getting involved in this space. Now a lot of people outsource it, and that's fine. But a lot of people want to do this in-house, and so they push out their MVP. They do what they got to do to kind of get that off the ground. But they're baking security in after the fact. We all know that's just not a recipe for success. So what we want to do is bake it in early. Everyone's heard shift left. That's what we're really shooting for. And some of these new organizations that are getting into it now, they're actually at an advantage because previously it was a very manual process. There weren't a lot of tools that helped automate it. There wasn't a lot of support to create a great CI/CD pipeline. It was very, it just wasn't smooth and efficient because we just didn't have the tools. So now people getting into it, they can actually get through and do the fundamentals of AppSec a lot easier than before. Just even in the last 5 years, what we have available now makes putting AppSec in the CI/CD pipeline is super easy. So let's go through some of the components of AppSec for pipelines. So first of all, like any other programming off the ground, you need to kind of do your research. You need to understand your organization. You need to understand how you support your organization and go collect information on that. But on top of that, you want to talk to the teams involved. You want to talk to the people that are going to be using this day to day and really understand their workflow, understand their release cycle, all these things. Because what you want to do again is support the company's ability to deliver apps and not make security a roadblock. As soon as it's a roadblock, people are going to go around it. People are not going to buy into it, and your program is going to be at risk of just not functioning the way it's supposed to be. So let's talk about some of the components. There's a stakeholder communications. Like you said, you're about to roll something out. You're about to insert something else into someone's process. You need to talk to the people involved in that so they understand this is coming. You need a threat model, so we understand what we're looking at as far as vulnerabilities, what our company's priorities are. Fit that into it. You got to do an application inventory, so you're covering all your applications. If you're only doing some sort of AppSec for 20% of your organization, you're not really covering what you need to cover. Application architecture, understand kind of how everything's built together, how everything's intertwined, what services talk together, what workloads talk together. Program strategy, again, as a CISO, I have to sit down and think, like, what's the strategy of a program? What's the ultimate outcome we're trying to get to? You need some assessment tools, vulnerability management, documentation, and continuous improvement. Let's talk about some of the building blocks for AppSec. Now, again, my view is that almost all organizations have to kind of tailor fit their program to support the organization. You can't just cookie cutter and copy and paste what someone else is doing. Otherwise, it's just not going to fit. But there's these building blocks, and you can use these interchangeably to kind of build out what you need for your the secure software development lifecycle, Git, CI/CD pipeline, containers, infrastructure as code, the SaaS, DAS, and all different scanning tools, and some pen tests. These are things you can take together to build a pretty good AppSec program. Like I said, where you put these in the process, if you're pen testing first, if you're pen testing continuously, that's all really dependent on the workflow of your developers and your organization. But these are just some of the main components you need to be familiar with and ready to hopefully utilizing to secure your apps. Let's talk about the evolution of AppSec. It was, like I mentioned before, it was a lot harder before than it is now. So before, there was a lot of manual code review. It was very cumbersome, time consuming. It took not just developer time, but senior developer time to sit down and look at junior developers' work. It was a very costly and inefficient way of doing it. Then we moved to the spreadsheet for, spreadsheets for days. We were taking them stuff from the code review, putting in all these spreadsheets, tracking vulnerabilities with these spreadsheets that would just become just ever longer because, it's such an inefficient system. You just keep adding to the vulnerabilities, keep adding to the issues, and you're very little, not chipping away at them very well because it's, you don't have any sort of automated process. Whereas these days you can have automated merge requests and reports and all these things, automatic remediations. You can't automate everything, but you can automate enough of the small pieces that frees you up to kind of then do the stuff you need to do to tackle the more one-offs and harder things that you need to improve for the AppSec. So, things like patching and whatnot, it doesn't have to be cumbersome now like it was just even 5 years ago. Let's talk about some of the trends right now in AppSec. So, like I mentioned before, previously very cumbersome, very manual. Now we're starting to embed tools into the DevOps teams. We're talking, container security. Containers first came out. There wasn't a lot of thought products or kind of knowledge around how to harden the containers. Infrastructure as a code security, again, if Terraform comes out, everyone's using it, but no one's really sitting down and other than manually kind of reviewing things and then pen testing afterwards, thinking about infrastructure as a code security itself. Is there hard-coded secrets in there? Is there things that just don't need to be in the infrastructure in the code itself, or need to be referenced differently? These are all relatively new things that make us much more secure, but even just a couple of years ago, it was a very manual process. You want to aggregate a vulnerability management process. Again, there's scanners and different types of vulnerability management tools. It seems like you might have to have 2 or 3 to cover all aspects of it. That's starting to get consolidated, and that's a good sign for the overall process. SaaS and DAS integration, again, these used to be not very great tools in the last 10 years. Now they're becoming amazing, and now they're starting to get integrated and kind of do more than just one piece of the pie. Continuous cloud app monitoring. Again, since everything in the cloud's an API call, a lot of products are figuring out it's very easy to kind of figure out every single thing that's happened, every single action, and monitoring that to a good degree, whether it's AWS, GCP, Azure. There's a ton of different ways to plug into every single thing that's going on in your environment via API and getting some really rich, good use case alerts on when things are kind of deviation from the norm or clear violations of some rules you have set up. API security. API security is another one where a lot of people barely had API documentation, barely had schemas, never mind any sort of security around it. Now that, you know, people like Melissa and I have gone through and, you know, shown how easily they can hack financial institutions via APIs, they're starting to see a lot of, you know, process talk tools around this, and I think that's a really great thing. Functional AppSec testing, again, not something in the past that was super prevalent. Now we got, you know, probably got tons of options on tools on how you can do that. Curated vulnerability lists. Now, this is something that isn't necessarily a product. This is something that I kind of preach. The way I feel is when you have an AppSec program, the security team should be basically curating the vulnerability list for the developers, so they don't have to figure out themselves what the priorities are. So you don't just sit there and run something like Sneak, get like, hey, there's, you know, 10 criticals, 20 highs, you know, 40, you know, mediums. You don't just sit them a list of that and say, go do good things. You need to sit there, you know, especially at first, and go, okay, of all these things, these are the ones that you can remediate. These are the ones that have known exploits. These are the ones that blah, blah, blah. And you actually curate and give them a prioritized list so they know what to tackle first. If they have limited time, if they have 10% of their sprint cycle, they know. And so security teams really got to kind of pick up the slack on that, and give guidance to the developers. Over time, developers may pick up on it. They may be able to kind of run with it, but the security team's got to at least get that off the ground. DAS becoming more real time. Again, there was usually some delays on that, but now that we have continuous kind of dynamic testing that can go on in real time environments, we get a lot more updated, faster kind of intel on what's vulnerable on environment. That's a really good thing. Let's talk about some of the best practices. Start small. Everyone wants to plug in a tool, automate everything, and what they end up doing is end up automating a lot of noise, end up alienating a lot of people, because all of a sudden they've got, whether it's email alerts or Slack alerts or whatever it is, they end up getting bombarded with, okay, you've got 12,000 vulnerabilities because it's the first time you plug this in. That's just going to turn people off. So start small, start with a couple of projects, start with a small amount of people, clean up the noise before you start just pushing it out wide. You got to have release control. It's kind of fundamental. A lot of people don't have any sort of, or I wouldn't say a lot of people kind of fudge the process on that and kind of have some workarounds. Try to keep that strict so that everything's, you know, through the pipeline, and you don't have ways of having a side branch or something else that can still go to prod. Continuous improvement, whether it's fail fast or whatever your methodology is. You want to be able to, you know, fix things and innovate really fast. You want a nice clean pipeline that, you know, you can run, you know, through test to staging a prod really quickly, but also hit all your security checks. Define success early and often. You know, as far as the AppSec program, you got to have a goal, you know, and it's not just be secure, because that's, you know, that's too vague. You got to talk about specifically in our org, this is what our goal is for Q1 with our AppSec program, especially if you're just saying off the ground. We want to reduce developer time by, you know, patch management time by this. We want to reduce whatever it is. Have specific goals so you can define success and communicate those to leaders. And above all, support the developers. Again, this is something that makes a lot more work for them. They're just going to find ways around it. It's kind of human nature. Some of the pitfalls. Automating everything first. Again, it's second nature. If we can automate it, let's do that. But until you understand it, until you understand the ramifications, understand the scope of what you're setting up, if you automate everything, you might end up pushing some patches that end up breaking things because you haven't patched other dependencies or whatever it is. So start off walking, you know, or crawling. Crawl, walk, run is kind of my take on anything with this. Don't overwhelm developers. If you're not prioritizing vulns, you might have people spending a lot of time fixing things that aren't even really a concern compared to things that are, you know, more critical. So you have to have prioritization in there. It can't just be a list of thousands of vulns and they have to figure it out. Not considering mitigating controls. There are some things that, you know, are so locked down by 10 other controls, the security team can say, you know what, this one can take a minute you can patch this later, we can upgrade this later, we can upgrade the dependencies later on this, because not only is this behind the WAF and the Palo Alto firewall, and it's got EDR on it, and I've got, you know, 10 other tools on it, the likelihood of this vulnerability even executing, because it's, you know, whatever it is totally mitigated by these other controls. So, you know, AppSec is still section of your overall information security, and make sure you're thinking about what else you have around it, and taking, and using that in your assessment. Not knowing what apps you have, that's, again, comes down to the basics of information security. Have some sort of asset inventory. In this case, it's your apps. Not working with product. Again, you need to understand what your product's trying to achieve. You need to understand the goal of the product team, and you need to support them, because if there's no product, there's no InfoSec team. If there's no InfoSec team, there's no AppSec program. Accumulating too much technical debt. This is a very common one. Again, sometimes because you come in as a new leader and all of a sudden you plug in some tools and you find out that things haven't been updated in a very long time. Work to do that, but then set up a program where you don't find yourself in those shoes again. Death by Excel spreadsheets. I find a lot of times we have all these great fancy tools that they've got great reports, and we're still pulling everything into Excel spreadsheets. I prefer, like, hey, give people links to the actual report, give people links to the actual alert. Don't start creating a whole other system to track systems that are trackable within themselves. Try and take advantage of those, because people don't like manually cutting and pasting things into a sheet if you can export something. So work with that. Not having a process for emergency prod pushes. Again, if your pipeline's so kind of backed up with all these processes, you can't have a way to get something through an emergency to get yourself back up during, trading hours, or e-commerce site during business hours. Then and the company starts losing a lot of money because there's so many gates for security to get to prod to fix that. Then you're going to find yourself at risk of losing some of that, because you have to support the business first above all. Poor documentation. You may have a really great process, and then you may lose one or two key people, an architect, a senior DevOps person, and all of a sudden there's lost tribal knowledge, and no one knows how to fix something in the pipeline because there's one-off on a certain thing, and that just leads to failure. So definitely focus on documentation. So in conclusion, start with the basics, slowly improve programs over time, consider the time required for the developers and the product team, using the InfoSec team as a curator of what's important and not, enable other teams to embrace secure development practices. And with that, I am done. As long as there's no questions.
Awesome.
Thank you, Chris. I think there's one question, and that is probably an opinion here. If there were 3 top metrics people should monitor, what would they be? What is your take on that?
I'm going to say it's pretty org specific, but I'll sit there and kind of figure out generically. I would say you got to have something around timing on your merge request process. Something around timing as far as is there any delays to developers being able to push their stuff to test, staging, and prod? You gotta see where you gotta have metrics around where it's getting caught up in that process to make sure that there's no one part in there that's kind of weaker than others, that there's just lost inefficient time. I would say overall, I don't want to say things like vulnerabilities over time, but something that shows that you're actually decreasing the amount of total vulnerabilities in the environment, as opposed to just constantly adding and on a losing scale. I remember years ago, I was dealing with Tenable in a different situation. It's not necessarily AppSec, but the list of vulnerabilities just always increased, and the customer I was dealing with was chipping away to like 10%. It was going up by like 20%. And I sat down and said to him, like, look, we need to fundamentally change how we're approaching this, because if the list is getting longer and we're only chipping it very slowly, it's just going to, not only you're showing not progress, you're showing negative process. And that's not going to be a good story for you and your leaders. So something to show improvements there. Lastly, I would say something around how efficient your pipeline is and rooting out the issues before it goes to production. So if you're taking care of everything in staging and prod, and you're fixing these dependencies, in staging and then you should have less emergency pushes in prod for vulnerability type things. If you're doing everything right in your pipeline, there should be less emergency. Hey, we have to do a patch to prod because we didn't take care of it. We didn't catch it in staging a test. It happens after the fact. Sometimes we don't even know about a vulnerability, so it's in production, log4j and Spring Boot, like that happens. But that should be the exception, not the rule.
Thank you so much. One thing, like one comment in the chat, like really insightful talk. So people loved it. Thank you so much for doing this. And yeah, I think if you have more questions, feel free to go to our Discord channel and put up the questions there. Either Chris or somebody else who is also involved in that same area can answer them for you. So Chris, I want to thank you for this. The talk was well received. I think it's a great way to at least get some pointers how to start with AppSec. So thank you for that, and enjoy the rest of your day.
Thank you. Have a good one.
All right. So we're doing it again. You're touching the buttons. I'm not touching buttons anymore.
Wow, that was a great morning though. That was a whirlwind.
A lot of information, and you probably want to look back at talks. Well, rest assured, these talks will be published. I'm not saying when, because I don't want to rush the rest of the team. That takes a ton of.
I know they're cutting them as we go, aren't they? And trying to get them up on.
I know, but Sam and Nina, who are at the back end of this, are doing a tremendous job of making it. We're just the pretty faces, trying to present here and help you. But the big hands go to Sam and Nina, who are all doing this. But I think we're on a break, right?
Yeah, we're going to be on a break in a minute. I just wanted to say one last thing before we go, which is that if you want to get more involved with the DevSecOps community, you can get engaged with one of our fantastic chapters all over the world now, Brian. I think 18 countries, 4 continents. If there isn't a chapter near you, then you are more than welcome to start one and get folks in your area engaged. So you can find all the details of that on the DevSecCon website. Oh, there we go. Fantastic. We've even got a slide.
Absolutely. And I think we're on every continent nowadays, except for Antarctica. So if you are on Antarctica and you want to create a DevSecOps chapter, please do so, because then we can say we covered the whole world. But yeah, I got you.
Okay, we're going to go for how long a break are we going for? We're going for just under
10 minutes.
Minute break.
Yeah, 9 minutes.
And we'll be back.
All right. See you in a second.
And we're back.
I think it's better to put an intro video in. So here it goes. So if you were not awake, you are awake now. That is the whole point of it.
Good afternoon, folks. Welcome back to the EMEA leg of DevSecCon Lightning 2022. We are bang on time again, so we have to let's keep trying to keep this show on the road here. So let's bring our next speaker up. Good afternoon, Filipi. Filipi?
Yes, that's correct, Filipi.
Oh, right, cool. So without further ado, we'll get you straight on here. So we're already slightly behind. So let's put your screen up there, and Brian and I will take Kate and leave you to it.
Good luck. See you later.
Okay, see you guys.
It's up to you.
Okay, so thank you again, everyone, for staying here. So my name is Filipi Pires, and I'm talking here from Portugal. I'm Brazilian, by the way. And I decided just share my virtual machine here because we just have 15 minutes, I think, to talk. It's a small conversation, actually. So this is my GitHub, basically. So we can find different projects here. This is Philip86. It's very simple. And here we can find information about me and some projects. So actually now I'm working as a security research at Sapporo. Sapporo is a company from Switzerland. And I'm responsible for creating attack modules, checks, control checks, actually, for this product. And I'm not only that, but I'm security ambassador of SNCC and security advocate in different projects. And it's a pleasure, once again, stay here. And I'm one of the leads of the DEFCON groups in São Paulo. And it's very nice. It's a small community in São Paulo. And the idea is to exchange knowledge with the students. It's a community, you know. And yeah, so here we can find the small web page and about some information about me. So it's a philippires.com. So we can find here informations, presentation talks, not only DevSecOps, but about other topics like malware analysis and presentations in English, if you want, and in Spanish, in Portuguese language. Okay. And here's some articles published by me about some investigations that I made in different positions that I've worked. Okay, so let's talk our main topic today. And again, just as we have a short time, just to introducing just as a small informations first, not only talk about the, SaaS and DAST, but the point here is to explain. So probably you already heard about this SDLC, Software Development Lifecycle. So probably you already see this picture. The idea here is just to explain more about how you can put in the S in front of this. But not only, if you're putting this on the internet, you can see different approaches or different explanations. But the point here, it's very simple. How you can see for the security way for the development life cycle. This is the very simple thing here. And how the tools can help you to increase your security code, security environment during this development process. This is the idea here. So again, probably you already see these, the requirement, design, development, testing, and deployment. This is the cycle, as I mentioned here in the first picture, okay? And the second one here, you can see below the different approach using the security approach, actually looking from the risk assessment. So probably we need to see something before here, like security requirements, security risk assessment, threat modeling, design review, and statistical analysis using, for example, tools to help you, security testing, code review, and so on and so on. Here you can see another picture, very interesting. And you can see here the security requirements that I mentioned. And so when you design this and this security process, it's very interesting. You define those steps. If you see here, you have the main topics here, like I mentioned it, and the developer process here in the first. And the second one, you can see here the security standpoint inside of the development life cycle. This is the key. Just in theoretical part, maybe not bullshit part, but it's important part. It's theoretical part, but we can use in different tools to help you. Okay. Here, I would like to just explain just a simple definition about what is SAST and DAST. Not only that, but we can see more than one. For example, just a simple approach. For the SAST approach is a white box security testing. The idea here is to looking more inside of the applications. On the other hand, you have a DAST, for example. So when you have the application published, so you have an endpoint, you have an API published, so you can run the specifically tools to scanning this if you have some specifically for example, specifically vulnerability, you can use it, for example, for the SAST approach. The idea is to run specifically, you don't need to you don't need to deploy the application, because you will run the specifically tools to executing specifically code inside of this. You can finding different vulnerability inside of this, specifically as a DLC, as you can see here. It means that you can scan, you can run a specifically scanning inside of your code. In this case, for the DAST approach is different, because you've published the application. So probably you have more problem. It's more expensive to fix the vulnerability. You can compare both. Not only that, you have another different approach that I would like to mention. That it's a simple, again, so you can find different articles on the internet. You have a difference analysis, not only SAST, as I mentioned it, or DAST, but you have an SCA, like a software composition analysis. So for each library, you can, or if involves actually 30 parts or different components that you can put inside of your code, inside of your application. So you need to looking from this, because many, and nowadays, so we using different libraries, different components to increase our code. And many times we using the open source is not a problem. I really like to use an open source, by the way, but sometimes it's not maintained from the community. It's just a simple, the person creating specifically code, and after that forgot the code. So probably this code, or maybe this code can be vulnerable. And not only that, but you have an YAST, for example, is a mix of the YAST and a mix of the SAST and DAST, and now more not new, let's say this way, but we have a runtime application self-protection like a RESP. So when you run you can use it, for example, a specifically agent inside of your application to run, to try finding actually new vulnerabilities. Just to put in this, to clarify all those people and putting all those people in the same page. Okay, so let's suppose that you can see you have a specifically project, for example, in your locally, or maybe you can use in your CI/CD pipeline, for example. You can go, if you want, you can here in my repository here, I have and specifically your sec repository here, -demo. So we can find here many vulnerable codes here, and JavaScript and Java, and Golang, Kotlin, Node, PHP. So it's a specifically project. I will compare two different projects, actually, different approach. So we have here Snyk, an open source version, actually, and I will using another is RSec. It's another only SAST tool. So it's a two different open source, just to share the difference. But of course, you can scale more using Snyk, because you have an enterprise versions and other benefits that you can use. But I would like to show you these two different ideas about that. So here we have some specifically vulnerable codes, as I mentioned with you. So we have a different language here, so programming language. We have an API here. And not only that, but you can, after that, or before that, you need to install. So we can see here in Snyk documents, so we can use in here like a guidance to you. So what is Snyk? Probably you know what is, or so if you don't know, you can put it on the internet. So Snyk product, Snyk open source, probably you already heard. So just click in Snyk CLI, and you can go there and you can install running in, for example, Snyk code scanning, container scanning, infrastructure as a code to looking for your code. Remember the software development life cycle. This is important here. So after you install, again, so we don't have a time to install. I have here, or we don't have a time to go through all those steps in slowly, let's say this way. But so I have here all files here, or folders, actually the project that I have here vulnerable, as I mentioned it with you. So first, I will executing my sneak Linux in my locally. I will run the code and I will execute the test. Simple like this. So this is my main project, as I mentioned it, and as I show you here in the projects. Let's go again here in Pires 86. You can find here the same project, okay, that I have here in my CLI, as you can see here, okay? So I just simple like this executing because I will run out the code analysis scanning. So just clicking enter here, as you can see, I set here the path actually, because I download the binary here in this specific folder. And if you see here, just to run the testing and finding 3 vulnerabilities, as you can see here. The first one is median, using password hash with insufficient completion effort. And here is the explanation and the path. If you can see here, the solution using the hierarchy, not only because this is the root folder, as you can see here. So the performance running inside of this folder, and as you can see here, the execution going through the entire path. So here is the real path, as you can see here. So golang dash API hash util hash dash util doc go line 23. So of course I could, for example, running here a code to open here in my Visual Studio, for example, in my VS Code, to see what is exactly the line vulnerable. And as you can see here, the information about MD5. Here is another possibility. If you see here in PHP vulnerabilities, it's different in this case. And here is the SQL injection, okay? Not only that, but we can see here in my Sneak dashboard, you can find here the same project, as you can see here, Filipi or sec dash demo, okay? So if I click here, so I just integration these informations with my GitHub, as you can see here, the picture. And here it's very interesting because as you can see here, the same information that you see here, that you see in my CLI, okay? And it's another point interesting here in this case is about the information about the vulnerability, but you have here the full details. If you click here, you can go for the fix analysis. In some case, you have the fix on how you can fix this, like this, the recommendation from Sneak. So it's very interesting here, the explanation. So if you are a developer, for example, if you're watching now or if you're watching after, so probably you don't know much about the security. So here it's a very interesting and good opportunity to learn more about the security, okay? And here is, as you can see, the data flow inside exactly point where is the vulnerable code, and here's the fix analysis, okay? So very, very nice. And below, you can see the SQL injection and the same password, insufficient compute effort. So we have here the specifically code analysis to see, like a SAST, as I mentioned, a statistical analysis inside of the code. If you see here, you can see another open source project called AppSec. As I mentioned, just a comparison. So if I run here AppSec and click enter here, no, I need to start. Yeah, start is another. They will run, if you see here, the same path. So of course, just compare two tools, what should be the best tools, Filipi? Depends of your environment, depends of your programming language, depend your necessity. But of course, you have a Sneak that have more experience when you talk about the security. On the other hand, you have another AppSec. It's a very, very nice tools. By the way, I'm one of those responsible for creating these tools for the community created by the security team. It's very interesting. It's an open source, but it's only open source. In this case, we have an open source and enterprise version. It means that probably you have more features and more benefits and more intelligence just because of that, okay? But again, Filipi, what should be the best? You need to test, you need to compare, depends your necessity. That's the point here, okay? So of course, you can see here if you compare, I'm talking during the last 15 minutes. I need to finish, by the way. And you have a different performance when you run each tools. Okay, remember, of course, I'm running here in my virtual machine, and I'm doing the streaming the same time in the same machine. So, but you can see here the differences about the performance. But here you will see not the same, of course, not the same, but the similar result. Talk about the vulnerability. Of course, using different engines responsible for detect is this code, because in this case, this is Nick. You have an own engine responsible for run and analysis the code. And this case is when you talk about the ORSEC, we have a different engine. You have our ORSEC engine. Not only that, but you have another like a GoSec, like others engine inside of this responsible for run and to analyze the code. Okay, so I just wait to finish this simple running here. We don't have a time again to share the manager or other things or to compare other things. But for my point here to share you is the difference and the importance of the analysis that are important to execute in your environment, and how important you know creating this, as I mentioned to you, creating this idea. So not this is better. The looking from this process, risk assessment, first security requirements, after that creating threat modeling, designing review, looking from the architecture, and creating the security code scanning, as I mentioned it to you, or statistic analysis using tool to perform a specific analysis here. And not only that, security testing, and in the end, for example, you executing specifically penetration testing in your environment. Okay, so okay, I need to click enter because of that is slow. Sorry for that. I forgot to click in enter again. So the question is proceed. Yes, I forgot to click in enter. So now it's running the code. Sorry for my mistake here. So okay, I think we can finish here. So of course we'll be scanning here just to show, but we have, if you want, you can see I have other talks in my webpage again that I show you here more details about this, the ORSEC. So as you can see here, the language, the severity, the line. So it's the same, by the way, same vulnerability, MD5, as you can see here, the MD5. So the similar, and by the way, the severity is medium. In this case, the severity is low, but in this case, the confidence, if you think about the security and stuff like that, is high in this case. But okay, so I finish here my presentation. So I don't know if the people have some questions. It's a short time, I know, but
I think we have a second. We have a second for questions. I've got one question lined up, and let me put us.
Yeah, Brian first.
Thank you. Somebody started with which one is better to start with, SAST, DAST, or SCA, and how do you handle a vulnerability in an indirect library? Which is basically two questions in one. But what is your take on that, Filipi?
Yeah. Actually, it depends of the environment. It depends of the company, and depends of the budget. Many factors, of course, because actually, usually it depends. Because why it depends? Because, for example, if you have a company and you have an application, publish it. Probably you're looking for the DAST because you have a product. You have an application, publish it. So you can run the DAST after you publish it. So usually you can look in more in the first for the DAST. And the second way, the team's using the SAST approach, because you're looking from inside of the code, and not only the code. Usually you using some tools to help you for the SCA, because you looking from the components inside of your code that you need to run for the application, or maybe your application depends of this specifically third libraries or other components inside of your code. So usually it's not a rule, but usually it started for DAST, because probably you already heard about that. So the company think about security after they start the job. So I have a product, I publish it to the community, I publish it for the market, and after that, I need to prepare some security requirements. Let's see how the code works. So now I need to look in from the code. Oh my goodness! So what I need to do, and that's the point here.
Yeah,
And
absolutely.
about the library is basically so it's necessary to have to using tools to help you, because in the end of the day, is it your applications publish it.
And I
So
think I think it's also different per ecosystem. Like in some ecosystem, you can exclude libraries specifically, or you can override them by something. So with vulnerabilities in an indirect library, that's a bit of a puzzle. So, but thank you for this. And as always, if you have more questions, feel free to move over to our Discord channel, as you see
Exactly.
the URL over here, and Filipi will be more than happy to help you out with it. Thank you, Filipi, and great talk. And we go on to the next person that is already backstage. Let me put this one up. And Matt, will you do the honors to put Akshata? I hope I pronounced it correctly, because it is.
That's right.
Akshata. Okay, thank you. God, that's one.
Hi. Good afternoon or good morning, wherever you are in the world. So we are just about on time, I think. So let me get your slides on the screen, and we'll give you the floor.
Absolutely. It's Akshata, it's all up to you now. And
Cool.
we have your slides on board. We have you in screen. So take it away and blow them away. Thank you.
Thank you so much. So with that, let's get started. So today we are mainly going to discuss about zero trust security for your APIs. This is also one of my favorite topic, you can say. A brief introduction about myself. Currently I'm working as a developer advocate at MuleSoft, a Salesforce company, and I have been working on MuleSoft as a technology for over 5 years now. I've recently published a book as well, which is MuleSoft for Salesforce developers. It's available on Amazon. And yeah, I've been blogging, speaking at several sessions. So apart from this, I love photography and traveling. And yeah, I would be happy to connect with you guys, maybe over LinkedIn or on Twitter as well. So with that, what we'll be discussing today, quickly in this lightning session, is what is the need for API security, and mainly we'll be starting we'll be getting to know what is zero trust security, how do we implement zero trust security briefly, and then we'll also address all your questions about it. And yeah, just a forward-looking statement uh, for your purchasing decisions, definitely. So with that, let's get started. So we all know that the APIs have been actually increasing. I mean, the use of APIs has been increasing at an exponential rate, and over the past few years, the API security has actually been a severe concern. So almost 41% of organizations have supported API security, and that's a fact. But apart from this, APIs are actually proliferating in a different environment or different ecosystems, we can say. So with this API ecosystem expanding to different verticals or different areas or different cloud, you can say, so it gets difficult to manage all these APIs. And with all these issues, it's actually impacting the API security. So our API security is actually becoming the major concern. So you must have there might be, I mean, definitely there might be some GTA fans here. And even if you're not a GTA fan, you must have definitely heard this news sometime, some few months back, that there has been just before the GTA 6 game release, right? There was some major videos and stuff about the game which was leaked. And this has actually impacted the organization at a high level, I mean, from financial perspective. And that was quite a devastating effect. So there were also some news this was done by someone internal. I mean, there's no concrete information on that, but yeah, there was some news as well. So imagine an attack of this level on your organization or on your data security, which is impacting your security. If that can be so devastating that it is actually taking you down. So, and if this is done by someone who's an internal person, then how important is API security and whom should you be trusting? So that is the main question here. I mean, even relating to our topic, whom should you be actually trusting? So as zero trust security says, you should be trusting no one, and you should be always verifying whoever the entity is. So zero trust security is not just applying. I mean, in this session we'll be mainly talking about the API, but it's an architectural security framework, you can say, which is mainly applying to different enterprise technology system, different ecosystem. You can actually apply this on different kind of application and everywhere. But in this session, we are mainly and particularly interested in how do we apply zero trust security for your APIs. Before going ahead, let's see what are the four pillars or what are the main principles of zero trust security. So first one, as we said, the trust no one and always verify. which states that we are actually going to verify each and every entity who's going to send us request or who's going to ask us a request for. We are not going to blindly give access to anyone, or we are by default it's going to be deny. So that comes to our second principle as well. We are going to make sure that we are going to give the least amount of privileges to each of the users, and by default it's going to be deny. Just like the way we are using our, maybe you can say, a Word document, or we're sharing with someone, we make sure that it's not the editor rights that we are giving, we give them the commenter or viewer rights, which means that we are giving the least possible rights. After that, we'll be having full visibility and inspection. So as we said that the APIs have been sprawling into different environments, different ecosystem, it gets difficult to actually have a centralized control and where the data is coming from, how is the data being processed, or what is the incoming, outgoing data. To avoid this thing, we actually need a full visibility and full control over our entire API ecosystem. And that is like the thought principle, that how are we going to, we need to have full visibility and inspection. Apart from that, we are also concerned about the centralized management. As we said, like the APIs are sprawling across different environments, and that's the reason we do not have a centralized management system. And when a centralized management system lacks, like you're not able to have a full control over your APIs, and that's where there are loopholes in the security. So the 4 pillars, which you can say is like, we're not going to trust anyone, we're going to give the least privileges and access, and by default it will be deny. We're going to have a full visibility and control of our API, and we are going to do all these things via centralized management approach. So let's further extend this ideology, the architectural framework, Zero Trust security, to our APIs and see how we can achieve it. So if you see over here we have actually a pattern, a mesh-like architecture, wherein you can say your APIs, it could be mule, REST APIs, it could be any kind of API and different kinds of application. You can also see Workday's app, and all of these things, they're interconnected to each other in like a service, a mesh-like architecture. And there is a exchange of data going on. So when you have such a complex ecosystem of different end systems, APIs, and everything in place, how do you manage to achieve security for your architecture, for your ecosystem? So the question here is, how are you going to make sure that you're applying Zero Trust security? So the way is like using a layered security approach. So layered security approach means, in each level or each peripheral level or at every end, you're going to make sure that there is a security layer which has been enforced. So if you see the bigger rectangle, the red dots, which is like actually telling you that there is a layered security towards the edge, the outermost periphery, and the innermost, which says that at each and every component, wherever there is a request, response, or transaction taking place, you're applying an API security. And this security could be via terms of policy or any other security method which you wish to apply. We'll see like how are we going to apply them. So tools in action, this is a lightning one, so I'm not sure how much tools in action we'll be doing, but yeah, we'll just make sure like we'll be on time and we'll do it. So an order management system, that is what I've used for a reference here. So you can see like there are different end systems which are involved, like the desktop, laptop, the emailing system and all, and there are also different end systems towards the system, towards the lower edge, which is like Salesforce, Workday, they are connecting. So these are like the different APIs which are interconnecting with each other. They are fetching data from the backend system, and this is actually your API ecosystem or your infrastructure, your API ecosystem basically. So if you can see this m.dot components, you can assume that they are your APIs, and over them we have applied different policies like the rate limiting, custom policy, JWT policy, header injection. So at each and every stage, wherever there is an incoming record or wherever there is a transaction taking place, there is an incoming data and outgoing data. Basically, whenever there is an API call triggered, you're making sure that you're always verifying the call before providing the information to the user. So that is what we say Zero Trust security, and we're not trusting any of the call, no matter from whom is sending the request or whatsoever. Okay. Please feel free to drop your questions in between. Like, yeah, this is going to be a lightning session, but still, like, we'll try to cover most of them. So going ahead, like from the previous one itself, like we have seen that there was an architecture on which we are going to apply security at each level, each and every level. So this is an API which is like connecting with the backend system. You can say it's a database system, and I'm applying a JWT security policy at it. So similarly, we'll be applying the security policies across each and every endpoints, and that's how we're going to create a mesh of security. So suppose if there is a request coming from the upper layer, from my desktop or machine, and then it's coming all the way towards my Salesforce end, it has to pass through all the security stages at every end, and that's how I'm ensuring I'm securing this securing my API ecosystem. Okay. So now let us see. Yeah, we'll be coming on the MuleSoft side as well. MuleSoft is like a MuleSoft Anypoint platform. Basically, is the world's #1 integration and API platform. It's an API management tool, an iPaaS solution, which will be helping you to unlock your data, which will be helping you to manage your entire API lifecycle, your entire API ecosystem. You can design your APIs, build your APIs, publish your APIs to Exchange, and manage your APIs as well. I mean, you can apply security policies, you can have a full control over your API at one single place. So we'll definitely see more about it in the upcoming slides. But before going there, like, how do we apply zero trust security from a developer perspective? Because it's often misunderstood that API security, it's only, I mean, something for the senior devs or maybe for architects or the enterprise architects who are going to take care of security. But that's not correct. I mean, if you are aiming to achieve zero trust security at the developer stage or at every stakeholder level or at each and every level, there is some responsibility which you need to ensure that you're like taking care of. So we have these two developer personas. First is Maxi, who's an API developer, and second one is Dan, who's an API owner. So let's see how we can help these two, like as an API developer, as an API owner, how are we going to help these two to achieve API security and also to perform their task. So Maxi, who's an API developer, her task is to design API, okay, using the API first approach, and she is going to like build the application using this API. She's going to test this application. So how is she going to achieve all of this thing? And while she is building her API, how does she assures that the API security is taken care of? So let's go to Anypoint platform. Okay, sorry. So in Anypoint platform, like this is the Anypoint platform I was talking to you about, like the iPaaS solution, which is like going to take care of the API management tool, the iPaaS solution. So going ahead to the design center, this is the place where I'm actually going to design my API. It's not necessary you have to design your APIs here. You can design your API in any API editor tool or any tool which is of your choice, and you can import it here. But I'll be just opening one of the API which I already have for the demo purpose. Okay. And while Maxi is designing this API, she can ensure that she is applying some security standards to her API. She's applying some rule sets, governance rule set to her API. So let me just open this thing up. Okay. Using the design center, also like while it's been opening. Yeah, using the design center, you can actually build any kind of API. I mean, you can build the API specification, which could be REST API, or you can have your async APIs as well. If you're someone who's like completely new to API designing, it will be guiding you to the process as well, like how do you design your API. So yeah, API is already open. So if you see, I've already applied a secure by component over here. So although this is like an initial stage, I'm making sure that my API is bounded by the security policies or mechanism. At this stage, definitely my API won't be like, we are not going to validate it, but we can actually simulate it by using a mocking service. So suppose this is my endpoint, for which I have applied a basic authentication, and I try to send a send request. It will be giving me an error saying that the validation has failed, but as soon as I enter any random username password, it should be giving me a response. So this is like, you're not validating it, but you're actually simulating it. And this is how it will be when you're actually implementing your API. So right at the designing stage, I'm making sure that I'm applying some security standards so that the quality is maintained. I can also apply some security governance rule sets to my API. So the rule sets like security authentication best practices. So you guys must have used SonarQube or any other coding convention tools while you're designing your application, which gives you a response like there has been few bugs, the coding standards are not proper, the lines, the comments are not proper, something like that. So similarly, at the API design stage itself, you can ensure that you're applying like the security governance policies. Let me show you guys this thing in the files. Yeah. So if any of the security tags are not present, or if the best practices are not taken care while I'm designing an API, so it should be giving me an alert that my API is non-conformant and it is not matching the standards. So that is one thing you can do as a developer, that ensure that your design first approach while you're building your API is correct. You're taking care all the security perspective while you're designing the API. So this, you're preventing the further iterations while you're in the developing stage of the API or while you're in the consuming stage of the API. Okay. And Yeah, this is something. I mean, suppose if there is a new developer as well who's joining in and he's trying to work on this API. So if he misses any of this parameter, the security parameter, is if he forgets to add any of them, he'll be getting an alert or maybe an error in the API that he needs to add security parameter and he has missed it. So this way at the developer stage as well, you're ensuring that you're adding the API security. Okay. Moving ahead to the next one. Okay, this needs to be loaded. Okay. Sorry. So yeah, we have seen like how we have helped Maxi to build her APIs from the scratch and implement the test logic and following the security standards as well. So going ahead, we have Dan, who's an API owner, and his main responsibility, like as an API owner, what is your main responsibility is like to secure your API, to manage API, to apply some security policies, proxy, basically management of different. I mean, suppose if you're having hundreds of APIs and you need to manage them, so managing them under different framework or a different portal will be so difficult. So that's why you need to have a centralized portal, a centralized access where you're actually managing your API. So let us see. I mean, with respect to this previous diagram, which we have, I mean, the order management system use case which we have seen. So suppose if this is my layer of API ecosystem or this is my architecture. So at each and every API layer, I'm going to add an API policy. Okay, so here maybe we can see like how do we add a JWT policy to it or any of the policy. How do we achieve it at one place? Okay, so let's get back again to our API manager. So API manager is a second place which is actually responsible for managing all your APIs. You can apply alerts on your API. You can apply security policies on your API. You can manage your instance. And this is not just for MuleSoft application, no matter where your API is deployed. Suppose if I have one API which is deployed on maybe AWS and other is on Google Cloud or Azure, anywhere. So I can still manage all of them at one single place using the API manager. So this is how I've created an instance for my API, and the security policies which I've been speaking about. So you can definitely design your security policies from scratch, but there are, I mean, your custom policies, writing your any of the code, and then you can publish it. But there are already pre-existing policies, the security policies which are which are available for you, and they are not just from security capabilities; they are from like quality of service, compliance, transformation, and troubleshooting as well. But as we are mainly speaking about API security, we'll just go into the security tab and we'll see like what are the different policies we already have, the pre-existing one, and how easy it is to configure them. So I can see I've already applied the shareability policy. Maybe we can see basic authentication policy and see how easy it is to apply. I mean, all you need to do is just enter your username, password. You can select which API you want to apply your API policy. You can give username, password like MuleSoft, and then just apply the policy, and it will be applied to my API, which is deployed on the same cloud as well. I can have multiple API policies for particular API. I can group them. I can have some alerts created as well. If my API is not having a proper response time, if I'm getting some response time failure alerts, I can have alert, and the email will be sent out to me. Basically, you can create some different contracts as well. You can have your own SLA tiers which will be saying about your incoming traffic. So this is all about your API management and security which comes at one place. So as we have already applied the basic authentication policy, let me just click one of them. So yeah, this policy, we have also applied JWT policy. Let me show you guys the configuration of this policy. I mean, you might be having this conception that JWT policy, it's like a authentication authorization policy. It might be difficult to configure, but all you need to do is just select your algorithm, whichever you want. It could be HMAC or RSA or anything. And then the JWT key length, you can have your own key. You can validate the claims and all as well. So previously, you must have seen you have been doing all this validation from the maybe by writing your custom code or your own Java code. But this is like quite simple and easy to manage and also at one place. Okay. So all you need to do is just save this policy and that will be applied. So if you try to hit the request to this, it should be giving you an error just because I have already applied a token. But suppose if I am taking off the token, it should be giving me a failure that JWT token is required. So this is how I'm actually applying security at each and every endpoint. Okay. And the token generation and everything you can definitely do using the third-party tool, Okta, OAuth, or any other identity service provider. Okay. So this was actually all about the API security on the API owner part, like how we can help Dan as an API owner to achieve API security. So apart from this, like apart from a developer or an API owner perspective, what else you can do? So you make sure that you're building your application or your APIs on a secure foundation. Secure foundation as in if you're in a government project, you're following the government compliances or your organization's policy, the security policy, and you're making sure all the regulations and everything is taken care of. Deploy your API on a secure environment. Make sure your environment on which you're hosting your APIs is also protected one. Okay. And all this APIs and services which needs to be like constantly monitored. Okay. And maybe you can make them in a group where it gets easy for you to manage it. Club them in a groups and into API contracts, so that you're actually like you're being consistent throughout the APIs with the policies and how are you applying them. So the standardization also comes into place. So with this, we have seen how we have actually implemented all the 4 pillars. I mean, what was firstly the need for API security? Like what are the issues with API security? How uh, what are the industry issues we have been facing, and what is the need for API security? What is zero trust security? What are the 4 pillars? That is, firstly, don't trust anyone and always verify at each and every stage. Give the least amount of privileges, and by default, it should be denied. A third one being you're going to monitor and have a full control, proper visibility, and a centralized access. The fourth one, I mean, you're going to manage all the APIs and secure them at one place. We have also seen the MuleSoft's Anypoint platform, the capabilities, how you can build your APIs, you can share your APIs with others, you can host and manage your APIs at one place. And how do we apply policies? So there could be different kinds of policy. We have just seen like basic authentication and durability, but you could be having any of your policy of your choice. And there could be some places where you're not actually having a policy, or maybe no security as well. But make sure you're doing it. I mean, you're not doing that. You're just applying security policy, even a very basic one, at every stage, because that's what zero trust security states as well. Like, you're not trusting anyone. You're making sure and you're verifying that at each and every stage you're verifying them. So with that, I'm not sure, like yeah, the next step would be like you can join us like on MuleSoft community. You can learn more about the API management or iPaaS tool, and how you can build your APIs, how you can get started with the API development. You can watch us live on Twitch and learn more about like how cool things, what are the different stuff we have been doing. You can try Anypoint platform for free. So the one which we actually sorted is the Anypoint platform. It's you can get a 30 days free trial account, and you can get your hands on it. You can try different components. You can try API security, API management, API building, the entire API lifecycle using that one singular platform. So do give it a try. And then yeah, just a small help. I mean, you can just this is the book like MuleSoft for Salesforce developers. So if you're someone who's actually looking to get started with MuleSoft on your MuleSoft journey to learn MuleSoft, maybe you all can get this thing on Amazon, or maybe you can share with your friends who's like looking to get started on the MuleSoft journey. And yeah, so now maybe we can just take any questions if you guys have, or you can reach out to me as well on LinkedIn, Twitter, or yeah, I'll be happy to take all the questions you guys have.
Thank you so much, Akshata. Unfortunately, we are running late a bit. So I would suggest everybody to go to our DevSecCon community on Discord and try to ask your questions there. People
Definitely.
are more than happy to help you. Akshata will be more than happy to help you. So thank you for this great talk. I would love to chat even more. It was amazing. But I have to move on to the next one, because I see Rouan is already in backstage waiting for us. So thank you so much. We will.
Thank you so much for having me.
Absolutely, absolutely. And
Bye-bye.
see you later. Cheers. So let's bring up Rouan.
Hello.
Hello.
How's it going? I'm very well, thank you.
Well, actually, for us, it's quite okay. We don't have to do a lot, because yeah, you folks are doing all the work.
Excellent. So my first question is do you like pineapple pizza?
No.
No, that's a big no.
Because I don't hate myself.
No, and my Italian friends will kill me if I would say yes. That's the second thing. But like, I want to see more now. So like, the floor is yours, Ron. Take it away.
Excellent. I'm afraid I do like pineapple pizza, so I'm sorry to my Italian friends, but that is unfortunately the reality. So my name is Rouan. I work for a company called Haven. They are based in the UK. I'm based in South Africa. I'm in sunny Cape Town today, and I'm very excited to be here talking to you about reviewing code for security issues. And the question we want to ask ourselves when we look at some code is we want to say, is this okay? And as an engineer, I found this was a little bit of a difficult question for me to start with. And I had to go through a little bit of a learning journey to figure out how to review code for potential security issues. So my plan today is just to share some tips and tricks with you. I've got 8 things that you can do when you're busy reviewing code to try and help you spot security issues. And so I guess let's hop straight in and we can have a look at some of those together. First thing to say, though, is that relying on code review for catching security issues is a little bit too much pressure. Code reviews are fantastic for catching issues, but they can't be the only thing. So within your organization, you want to make sure that you're building some awareness, that people know about security issues, know what potential issues might crop up, that you're doing some threat modeling. That's basically a process I'm sure you know already, but it's a process of identifying what assets you have, which ones are valuable to others, how they might try and get to them, and what you need to put in place to mitigate that happening. And then lastly, doing some penetration testing, and I'm sure other things too. But the key point here is you can't all rest on code review, even though I'll show you some good tricks. So the first trick I want to show you, the first tip, is to always pay attention to where the input is going. So there are a few questions you want to ask yourself when you're busy reviewing some code. And it's worth pointing out here that when we're saying reviewing code, it could look like a few different things. It could be you reviewing a pull request or a merge request from a team member. It could be you reviewing your own code when or before you open your own pull request. It could be you reviewing the code of a pair that you're busy working with. So all of this kind of applies. I don't know why my slides keep changing. So there are a few questions you want to ask yourself when you're busy looking at some new. So first of all, in a change set, is there any new input? Secondly, have we changed the way that the input is handled? Maybe we used to store it in a database, and now we store it in a database and send it on a message broker. Maybe where it's stored is another question that you want to ask. So it's possible that it was stored in one place before, and now we're storing it somewhere else as well. Maybe we used to pop it in the database. Maybe it now goes in the database and in the logs. And lastly, and this is quite an interesting question, is you've got to think about how it's used later. So if some data comes in, we've got some input from a user. We know we shouldn't trust that. We're storing it, but we know we're not using it for anything else. Oh, but maybe we are. And so these are the kinds of things that you want to keep an eye out for when you're busy reviewing code. I did a fantastic secure coding course through Stanford a couple of years ago. And the key message I got is that the main way that people get into your system is by tricking you to mix data with instructions. So the basic idea, the picture here is about kind of a low-level memory trick to get you to have instructions in the part of the memory and that actually come from the data. And this mixing of data and code is also the reason we have things like cross-site scripting on websites. And so that's the thing to remember. Never trust data because someone might be tricking your system into using it as an instruction. Tip number 2 is, are the right AAA checks in place? So what is a AAA check? 1, authentication. So here we ask ourselves, have we checked the actor is who they say they are? So if someone is trying to do something on your website or your app, whatever it is, we have to make sure that they are who they say they are. Second, have we checked that they're allowed to do this? And this is quite a common issue that creeps into things. You need to do some sort of permission checking. Just because someone is authenticated with your system doesn't mean that they're allowed to do everything that you have on offer. Maybe they're not allowed to delete a user if they're just someone who has a profile on your website, for example. And lastly, auditing. And auditing will be different based on your company, based on your team, based on your requirements. But generally, for certain kinds of actions, you want to make a note of what happened, essentially. So you want to pop something in your logs, in your database, to say, hey, something happened here. Let's keep track of who did it, when did they do it. Here's a little screenshot of a code change that's introducing an authorization-related vulnerability. So if you have a look here, we've got 3 endpoints where people can post a profile. There's a get, a put, and a post. This change request that we're looking at is adding the put endpoint. And what you can see here is that we're checking if they're logged in, we're checking if the profile is valid, and we're updating the profile. And that code looks fine when you're reviewing it most of the time. But the trick here is that we don't have another piece of middleware that we have on that post, which says user matches request. And so with the code as it stands here, we know that someone is logged in, we know that they are who they say they are, but we would allow them to update any other user's profile. And that's problematic. We don't want that. So you got to make sure that you got those 3 A's covered when you're reviewing some code. Third, have the assets changed? And this was an interesting one to me. I never thought about the assets in this way. So let's say we have a website and we're storing some sort of information about a user. Some kinds of information need to be treated differently to other kinds of information. So 2 examples of that are personal data and payment information. So some things, just the list is longer than this, but emails, health information, credit cards, racial or ethnic origin, political or religious info, all of these things need to be taken special care of. And so when a pull request comes across your desk, you should make sure that the shape of the data hasn't changed. Because if the shape of the data changes in a certain way, it might mean that we need to treat our data differently. So for example, maybe we never used to care about how secure our database was because we weren't storing anything that was particularly secure. But now all of a sudden we have user accounts and we have information that belongs to a person. So we need to make sure that we're cracking down on that more. Here's an example. Here's a pull request for our little profile website. Imagine an online dating profile website. And you can see a pull request here. We're adding some new fields. We're adding ideal date, sunset, stroll on the beach. We're adding sexual orientation, so we can match the right people with the right people. We're adding favorite color and favorite food, pizza with pineapple on it. But this change adds sexual orientation as a field. And sexual orientation is a protected piece of information in many parts of the world. In Europe, it's under what's called GDPR. And so what that means is this is protected data. We have to take super special care of this data. We're not even allowed to keep this data unless we have a very good reason to do so and the consent of the user. And so that's always something to keep an eye out for. All right, the next thing that we want to look out for, number 4, is are you leaking data? So for this one, you want to try and think about whether you've got information that you are releasing to other people accidentally. And this happens more often than you might think. The most common example is that your API might be returning extra bits. So maybe you have information about a user, but you're returning more than the page. Maybe there's a page, it wants to show a picture of the user and their name, but we're also returning their home address. Whoops, that's not great because then attackers can use that to get extra information about your customers. Second one that happens quite commonly is, are you logging stuff that you shouldn't? So maybe you're logging personal information, which isn't great because normally the kinds of protections that you put on your database to make sure that you're not leaking personal information are not the same ones that you put on your logs. Maybe you're logging something like a bearer token when an authentication request fails to a third party, and now you've got secrets in your logs. And a nice little trick to keep in mind to make sure that you're not leaking any data is to make sure that you don't keep anything that you don't need. If you don't have it, you can't leak it. Right. Here's a little trick as well. It's super helpful to make sure that your APIs stay a little bit more secure. You can see here that we've got a profile object, and what we're doing is we're pulling off the first name and the avatar URL from that, and we're sending that back to our client. Very simple, but in most cases, a lot of engineers will return the whole profile. And having this kind of allow list of fields that we want to send back to our clients is a very simple trick, keeps us nice and safe, and is a good thing to keep an eye out for when you're busy reviewing code. Okay, next one. Are there any new dependencies? And this is a particularly hot topic at the moment due to something called supply chain attacks. And so the idea is that someone is going to inject scary code into your application, but they're going to do it quite far away from your actual code. And dependencies are one way in which they can do this. So when you're looking at a new dependency, if a pull request comes across your desk and there is a new entry into a package.json or whatever package manager you're using, ask yourself, do a little bit of research. Is the library trusted? Is it popular? Is it well maintained? And lastly, do you really need it? Maybe you could do it with some plain code without a dependency at all. Here's an example of, from a pull request that I opened up against an application, an open source library a number of years ago. And there was this is a JavaScript application, and you can see that there's a package that was there called net. And net is a built-in Node library. And so in your application, you can say import net from net, and it just works. You don't need a dependency for that. But somehow this is crept into the code. And net was a real package on NPM, didn't have a lot of information about it. There wasn't any code there really, it looked like. But you could see how that squatting on a name like that would allow someone to inject malicious code into your application. So I opened a pull request to remove it in this case, but this is a really great thing to keep an eye out for. You want to make sure that any new dependency is sound. Next up, has the config changed? Misconfiguration is a super common cause of security issues. Most of, that's probably an exaggeration, lots and lots and lots of the examples that you see in the news of information getting leaked, of security hacks, are due to misconfiguration. It's very, very easy to make a misconfiguration issue. You can see from the screenshot there, Microsoft had a bit of a whoopsie, and they lost 250 million customer service records due to some, just a checkbox on a database, really, right? Should this be secure, yes or no? Didn't tick the box. A really, really helpful trick here is that to remember that if your code, if your config isn't code, you can't review it. So make a real effort to have your infrastructure defined as code, your configuration as code, because then changes to configuration can be reviewed. A couple of years ago, there were a lot of issues with people not securing their Amazon AWS S3 buckets. You can see that little red exclamation mark there saying that public access blocking is off. Whoops. Suddenly all of your customers' information is available to anyone who's clever enough to find it. Not great. Make sure that things are locked down. Number 7, this is our second last one. Ask yourself if anything is being cached. The reason this is really important is particularly when dealing with user-specific information. If your caching is wrong, you're going to show Susan's information to Tandor, and that is going to be a problem because you've cached it when Susan was busy looking at hers. It's really important that everyone in your organization, when they are reviewing pull requests and when they're writing code, understands the default cache behavior. And it's really helpful to have good cache keys as well. Number 8, this is the last trick. If you're short on time, if you don't have the time to look everything in a pull request, the handy trick is to focus on where the data enters and leaves your systems. Check the borders. So if you're having a web request that you're dealing with, have a look at what data is coming in. When we put it into a database or put it on a queue, have a look at what data is leaving. Those are the 2 most important places to start when you're reviewing a code for security issues. I'm going to share a few tips really quickly that have helped me learn a lot about secure coding. The first thing is to find yourself a security mentor. Find someone who knows more about security than you do. Ask them questions, hear what they have to say, see who they follow on social media, and just try and get a bit closer to what's going on. Secondly, if at your company you have things called post-mortems when there are security issues, turn up to those. Learn about them, read the notes, see what went wrong, and see if you can learn from it. I also started listening to a podcast called Smashing Security. It's amazing. It's not a particularly technical podcast. It's just a very entertaining one. And people talk about all kinds of things that go wrong with, I don't know, smart fridges being hacked and things like that. And it's just kind of like a funny take and kind of gets you thinking about security. And the next one here is to offer help during pen tests. Pen tests can be difficult to organize at organizations. So it's really helpful if there's an engineer there saying, hey, I'm willing to help. I'm happy to help you talk to all the team leads and figure out what needs to be tested and when, because then you can kind of get close to the action. And lastly, find a good security course online. There are a few of them, maybe one specific to the language that you're coding in most of the time. All right. And a quick recap before I finish up. These are the 8 things you want to keep an eye on. Check your inputs. Make sure you got the right AAA checks. Check your asset type. Has it changed? Make sure you're not leaking any data that you shouldn't be leaking. Check the dependencies to make sure they're not dodgy. Make sure your configuration is code and that there aren't any bad changes. Make sure that you understand your caching rules and that those are all okay and being respected and that you're not going to leak one person's information to another one. And lastly, check those boundaries. Those are the main places where you want to have a look. So that's everything that I wanted to tell you today. If there's time, I'm happy to answer some questions. Otherwise, you can catch me online later.
Wow. Thanks. That was like super concise, super
Yeah, that's
actionable,
great.
and very, very much
Good
to the
talk.
point. I got some questions, or not basically not questions, but just remarks like great talk, useful advice. So people love it, and I think this is the benchmark of what a lightning talk should do. And if you put that in 15 minutes, I mean, great job, man. I appreciate
That's
this.
very kind of you to say.
This so much. So I am sure that when the video goes up, because we basically are recording everything, comes up, it will be a smasher and people will share it right away. First of all, I want to bring in my fellow sneak person. Well, basically, I have to be kind to him because he's my manager. Hi, Rouan.
Hey, everyone, what's up? It's amazing talk, Rouan.
For the last part of this thing, you're taking over. So I would say Matt, Rouan.
I've got the better co-host now. So
thank
the
you.
professionals have arrived.
Oh, I appreciate
Feels
it.
so much better now, right, Matt?
Hey, you know what? Bye.
Thank you, Brian, for all your help this morning. It's been awesome. And thank you, Rouan. We'll let you go if we need to move on, unfortunately. But if folks have questions for Rouan, I'm sure you can either get on the Discord, which I'll put on the screen again. Oh, no, that's the wrong one. It's this one. And or contact you offline. Right, and thank you again for your talk. So let's, I'm going to add our next speaker in, and I'm going to go and try the Polish pronunciation here. Zbyszek? How close
very
am I?
nice.
Awesome.
He also goes by Vivi, if you're a good friend. That also works, right?
Yeah, all English speakers, please use just the first two letters. I'm not going to put you through pronouncing that on a daily basis.
Fantastic. Well,
yeah.
if you'd like to share your screen,
sure.
You're all set up and ready to go.
Yep. Oh, yeah. Let's choose this one.
Well, you did,
and you should see my slides now.
Yeah, we got you there. So let's crack on, and Rouan and I will move ourselves out, and the floor is yours.
Okay, thank you. Yes, I'm running code from the internet, and what can you do about it? So imagine I offered you a string of text that pretty much looks like written in JavaScript. Would you put that in your application and run it? Yeah. Would you do that if I offered it as a tar.gz file? Does that help? I guess so, because that's what an NPM package is, and everyone keeps chewing on them every day in, day out. We do that a lot, and I just wanted to make sure that you understand. NPM packages are just bits of code in a tar.gz file, and these are inputs from the internet that everyone tells you to sanitize. Do you sanitize your NPM packages? Good question, right? Probably don't. We're just taking them and gobbling them up. And don't get me wrong, I do that as well, and I love it. I've been doing that for a while. Actually, this animation, a previous version of this animation, is something I showed a while back on a different Snyk event before I even joined Lava Mode, and this talk is going to mention Lava Mode. So it's been a journey. I first started looking into what bad could happen around 2015. And the number of bad things that can happen was just increasing. So let's not focus on vulnerable dependencies this time. Let's focus on malicious dependencies. There can be different types of malicious dependencies attacking you at different points of your application's lifecycle. So let's now think about what bad things can happen either delayed slightly or right away. Yeah, story time. This is going to be a story where you meet Dave, who's a software engineer, and you meet Anon, who's a malicious hacker. Dave has a project. Dave decides to install some dependencies, obviously. npm install, yarn install. Yeah, let's get them rolling. Anon happens to control one of the packages somewhere deep in the dependency tree through some typo squatting. Maybe a maintainer of something vaguely useful installed a package that seemed to be what they wanted, but they kind of installed it and forgot. It's not being used, but it's there, right? So what would Dave think? I'm not running that, right? I'm just running my application and my build. I'm not running your package. Well, that's what you think, replies Anon, because Anon knows about lifecycle scripts, right? And I guess everyone listening to this already knows where this is going about lifecycle scripts. So then Dave decides to defend against post-install by spawning a new container, running installation there instead of the main CI process, taking node modules and storing them somewhere, and then destroying the container. So Dave assumes now there's nothing the evil hacker can do. Well, that's not what the evil hacker is thinking now. So the evil hacker takes a post-install script and runs a bit more code that finds TypeScript and delivers a payload into the TypeScript compiler's compiled sources in node modules. And now when you transfer node modules away, you're still vulnerable because this TypeScript compiler turned evil. This is what I've been showing way back. So if you want a demo, there's a demo of this. Check my earlier presentations. Now, this, I hope you also know, you can ignore scripts with npm and yarn. You can ignore post-install scripts and all the lifecycle. And then you end up with a dilemma. So I have a dependency that really needs the lifecycle script. What do I do then? Well, I run npm rebuild bcrypt because bcrypt needs to be built for it to work in my application, right? And that's what Anon was counting that Dave would do. Because npm CLI and yarn CLI and other CLIs, they trust packages to call themselves what they are actually called sometimes. So, you know, it's kind of hard to replace bcrypt on npm, but you don't have to replace it on npm. You can replace it in your own package's dependencies with anything that doesn't go through scrutiny, like a bundled dependency. Oopsie. Dave is surprised. What could Dave do in that situation other than exclaiming profanity? Well, Dave can look for a tool that could help him. And that's where Lava Mode comes in. So Lava Mode helps you set up and drive your repository in a way that the scripts that Anon was using are no longer working. So when you set up allow scripts, you get npmrc with ignore script permanently enabled, and then the auto generation command will give you policies that you can edit in your package JSON. So we can see that there's a bunch of stuff in there, and you can decide by setting them to true that you want this particular thing to work. And the benefit of using allow scripts is that it differentiates packages. So it will notice the difference between bcrypt and something deeply nested as a bundled dependency that happens to call itself bcrypt. And you will get two entries, and you can decide which of them should work. Now, that's not the end. So if you've been following news, and Anon was following news, Socket Security published this new trick where you can decide that the command you expose from your package, instead of being called like TSC, for example, which is common for TypeScript, right? You should know that. You can decide that the command you're exposing is called npm or node. And that's going to resolve in the scripts you run from your package JSON, right? So when you do npm run lint with this evil package installed, it's going to run the evil plots.js file that was named npm by the designer of the package. Well, that's not good, but if you continue reading the README file on allow scripts, you will notice that allow scripts is introducing an experimental feature where it can also control linking bins, not just the post-install scripts. So just a matter of a tiny change here and there to control that as well. And if you want a demo, there's a demo of that. Check out the original article from socket.dev. All right, so what now? Well, Anon is upset because NPM said it was a feature that they couldn't break, and now people are breaking that feature and not allowing him to take over the repositories. That's not good. Well, that marks the end of the first chapter of our story. So, and in that moment, we can say the installation process was protected, at least from the malicious scripts, right? There's a bunch of other things we could talk about, but we won't. Let's focus on a more serious threat where Anon is going to put a bit more effort into getting into your dependencies and find something that you actually use that they can take over. So now this gets more serious because you're running code. So Anon introduces a bit of bad code into the package. Would you look into your node modules to find it? Well, there's a bunch of tools, not excluding SNCC, obviously. SNCC also does that, that go through all of the code in your dependencies to find these things. But Anon goes further and obfuscates the code. Well, is this obfuscation good enough? Are you still reading? Well, it still says HTTPS and GitHub token. Okay, let's go further. Should I keep going? I can keep going. This is the same code, but with the heavy obfuscation, which is now 70 kilobytes of just JavaScript, and it runs. If you try to deobfuscate it, it stops running. So it's a bit harder to figure out. And this is what people do. There's packages like if you look up Lofi Gang, one of the recent exploits, they published packages that had 4 layers of obfuscation. Okay, but yes, there's an app for that. Well, Dave already found lava mode, and allow scripts is just a tiny tool. The main functionality of lava mode that I want to focus on here is runtime protections. So what you need to do is you need to generate a policy for your code running. In this case, let's look at a build script. So we have build.js that we run. And we now, instead of doing node build.js, do lava mode build.js. And then we have a command for generating the policy. And the policy kind of looks something like this. This is a small section, assuming the evil package was clear, not obfuscated. This is what you would see for that evil package's code. So we say request from HTTPS module from built-ins is used, and process.env from globals is being used. Okay, so now I can override anything by just saying false, or if the package was obfuscated, the initial scan to generate the policy would not find the usage. And what's great about what happens next is that we only read the code with some ASTs from lava mode when generating the policy. But when the policy is applied, well, that happens on the level of the language itself. So now when you run build, you will get an error saying evil package requested HTTPS. And that was not in the policy, so require HTTPS will throw an error. If that's not the first thing happening, well, you might get a different error that says type error could not read env from undefined, because you know what? Process is not one of the globals available to this particular package. Meanwhile, everything else could have access to process and use it. Wait, how? How is this done? That's impossible, right? Every package has different globals. Well, let's take a peek inside. Okay, story's over. Now we get into what's behind Lava Mode. And the main technology behind Lava Mode is SES, short for Secure ECMAScript. This is a tool that allows putting each package in its own compartment, which is a box that lets you define how things are loaded and, most of all, which globals are going to be available. So every compartment gets a different object to be their globals if we want to. And the best thing is compartments are becoming part of the language. So there's work in TC39 to put compartments into the language with all the functionality necessary for spinning them up. It's still early. So yeah, you won't be able to get an update on your browser or Node.js tomorrow and get this feature. But it's being worked on, and it will get into the language eventually. Now, SES consists of three major things. So there's compartment for scope isolation. There's lockdown, which makes your entire realm, or as V8 people like to call it, context secure. This means no more prototype pollution attacks that you could use to escape your compartment. And then harden is for use with the actual program when you want an object from your program that you pass into a different piece of code that you don't trust to not be modifiable. Okay? Wait. So JavaScript is being designed to be secure. Well, no, JavaScript is. It just happens to be a good design for security because the language itself is standardized with ECMA's TC39. Meanwhile, all the powerful features are standardized elsewhere in W3C or in Node.js working groups. If you take Conway's law that says every organization is going to deliver software whose shape resembles the communication structure of that organization, it means we get good separation between the language and the APIs. So any powerful API is only reachable through scope or by requiring it. And since compartment controls all of that, we get hardened JavaScript as a result. Okay, that was a lot. Recap time. First, install time protections with allow scripts. You can install allow scripts in your repository, run the 2 commands to configure it, and you're protected from lifecycle scripts. Additional protections against bins that we're rolling out about now. Runtime protections with Lava Mode and a policy. Introducing that is a bit more work because you need to refine your policy a bit. But this is super powerful. And behind all of that, there's hardened JavaScript with SES. Also, you can use SES directly if you're building a tool or product where you want to run untrusted code and get the benefit from that without the risk. And Lava Mode is protecting installation, build, and runtime of MetaMask, which is being used by about 30 million people. And there is a future extension system for MetaMask that uses SES directly to run someone else's functionality within MetaMask, which is also interesting. And that's based on guarantees that SES gives us. It's already available. You can use it. You can play with it. If you want to know more about SES, check out my earlier talk where I get into detail how the current shim how it works right now. And then you can look at Mark Miller's talk. Mark Miller is the inventor of SaaS. And there's a lot more information about the principle of how it's working and why it's the way it is. And I'm offering to help you set up Lava Mode in your project. So either scan this or go to Nauctor.pl. You can find means to contact me there. And I'm obviously joining Discord. Yeah, that's it. Thanks for watching.
Awesome. Thank you very much. This is your specialist field, Rouan, so I'll...
Hey! That was fun.
Yep. So do we have questions, or do you want to see a demo?
I personally thought that JavaScript was already secure, but looks to see there's still some work to do.
So we've got lots of good comments here. Great presentation. I do have a question, actually. Let's see if we can, from the... Is it secure to host passwords within package.json? I'm not sure whether that's a serious question or not, but...
It's always secure. It's JavaScript.
Well, you shouldn't put your passwords anywhere that's accessible to anyone else. And since package.json tends to be in a repository, definitely not a good idea.
Yeah, great. Okay, well, I think we're just about on time. So thank you again for that fantastic talk. I'm going to drop you out there, and Rouan and I have some final remarks to do before we close up today's session. So thank you to everybody who's taken part today. Thank you to all our fantastic speakers. Thank you to everyone who's attended. Thank you to my brilliant co-hosts. I'm pointing the wrong way. Rouan Tal, who's just disappeared, and Brian Vermeer, who has left us slightly earlier. Thank you to all our team of fantastic backstage folks, particularly Sam and Nina. A couple of other things. We're going to be in a couple of hours' time. The Americas session will be starting, hosted by my good friends Brian Clark and Micah Silverman. Some brilliant talks there. I just had a quick look through the agenda. We have talks on zero trust networking, on managing security incidents, on infrastructure as code security. So a whole bunch of stuff there that's going to be super interesting for those of you who can join. There you are. What happened?
I don't know. Internet is very, 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 very.
The internet.
Stable today.
So the one other thing that we're doing over this in each of the regions is announcing the results of the annual DevSecOps Leadership Awards. So if you were there in APJ and already know the results of these awards, please no spoilers. Let's get the slides on the screen. Do you want to talk us through the first ones, Rouan?
Yeah, sure. I feel that we should also add some nice background music. Maybe start dancing. What do you think?
Yeah, that's good. That's good. Right. Okay. Right. So the first award, Inspiring DevSecOps Individual, and the nominations were. This is the bit.
Should I go through it? What's going on there? Because I'm getting delayed. Okay, so let's see. We have so this is DevSecOps Individuals, and so we have Keith Betterham, right? Nomination 1. Second, Manikandan Tanjamani. Hope I'm pronouncing that correctly. And Lena Smart. Yeah, you ready for this?
Yeah, and the winner is
All Lovely Individuals. And the winner goes to Manny. Thank you, Manny, for everything you've done, for all the work that you have put out for container security. Doing that with Telstra, which is like a really, really big organization, is obviously a lot of work, I guess. So Thank you for making the security team there as well shine and do what's needed to keep us all protected. So thank you, Manny.
Fantastic. So the next award is for Outstanding DevSecOps Community. And our three nominees for this were Hacking with Farah, DevSecOps Netherlands, and We Hack Purple, all fantastic communities. I'm very familiar with all of them. And the winner is Hacking with Farah. Fantastic. So congratulations to Farah and to all those community members in that fantastic community. Go check them out. And finally,
I've been watching a lot of Farah's videos too as well. She does
brilliant.
Really good job there.
Most effective DevSecOps team. Do you want to do this one, Rouan?
Yeah, sure. I'll take that. So we have the CNCF SIG security group doing a bunch of really good work on essentially securing and advocating for security best practices, which is good for all of us in the ecosystem. We have SigStore there, which essentially, well, if you haven't heard about SigStore, you've probably been living under a rock. So
one of the most important pieces of security software of recent years, I would say, and having a fantastic impact in the world of open source software supply chains.
Exactly. So if you haven't heard about it, or this is new to you, which is just fine, there's like a ton of stuff to learn and do with security things. So go and Google SigStore or ask the OpenAI bot, what is SigStore? I'm sure you're going to get some help. If you haven't heard about OpenAI, open Twitter. Anyway, we'll continue it. The last one being Citibank and the security team there. So really, we're going to go to the winner, or are we? Yeah. Most effective DevSecOps team is Citibank.
Congratulations to them. I saw a talk at Kubernetes Community Days on some of the work they're doing around securing their software supply chains at very large scale, many hundreds and if not thousands of applications, and thousands and thousands and thousands of dependencies, and building some really interesting systems there to be able to automate all of this stuff at scale. So congratulations to them. Right. There we go. Congratulations to everyone. Let's get rid of that one. So last few things. Do join all of the DevSecCon community on Discord at the URL that's on the screen there.
Chapters too.
It's chapters. Where's my chapters slide?
We have DevSecCon chapters all over the world.
Someone magical.
Next to you.
Yeah. So as we said before, there's now 18 I think, chapters all around the world, multiple continents. If there isn't one near you, please get involved, create one. We'll support you. It's a great way to build the security community in your area. So let's and our Discord community. So how do I get rid of that one? Sorry, I'm trying to press the button. See it? Right, there we go. Right. So, Rouan, that's been it. Short and sweet, but thank you for all of your help. It's great to see you, and I hope you're going to stick around and join the Americas live stream a little bit later. So I think that's us. I do need to put up a final. Where are we? There we go. So thank you, folks.
There we go. Yes.